do this. Thank you for starting the recording. So let's get to it. The agenda for today's discussion and tomorrow's. So we'll have we'll do this. So I'm assuming everybody's in Central Time, but in Central Time this will be 9 to 12 today. So that would be the first half of the day, and then tomorrow again 9 to 12. We'll have the CTF, or the practical part of today's session. So what that means is we've divided the session into two main parts. Number one, we'll talk about the high-level security concepts, the introduction, the web application 101, and HTTP and web server client relationships and that sort of thing. We'll do some vulnerability deep dives as well. So there's three in particular that we'll discuss today: cross-site scripting, cross-site request forgery, and injection attacks. We'll see if we have time for more, but I doubt it, because I do want to go into the details of some of these vulnerabilities. And then tomorrow we'll set up Burp Suite, which is an industry standard tool for doing web application security testing. And then there's a hands-on portion. So there you will be able to try on some of these attacks, or these basically malicious injections and scripting attempts yourself. And finally, we have a CTF. So a CTF, if you're not familiar with it, is basically a capture the flag challenge. And what that does is we have, in the world of security, several different kinds of CTF challenges available, trying to teach you different concepts. So we pick a concept at a time, and we make an intentionally vulnerable application or server. And then we basically ask the participants to go and attack it and see if they can capture that flag. It basically will require you to go through some of these security hurdles, and then basically get to the objective, which is capture the flag. All right, so we'll start with introductions very quickly. My name is Pranshu. I am a principal security architect at Motorola Solutions. And before joining Motorola Solutions, I was a PhD candidate at Michigan State. So do we have any Spartans here? Let me see if anybody responds in the chat, but any Spartans in the house? I'm not seeing anything.
I mean, for Michigan, right? I'm just kidding.
Yeah. I was going to say, as long as we don't have any Buckeyes or any Wolverines in the house, we're good, right?
Two slides down, Pranshu, is where I'm living right now, right?
Oh yeah, Ohio. All right, so yeah, so I completed my PhD at Michigan State in computer science, and the thesis that I did was focused on basically malware and in ransomware in particular. So I did a lot of malware reverse engineering. I applied concepts of applied cryptography. And then I also used digital forensics, which is basically looking at artifacts left behind on your systems, on your machines, and trying to piece things together. So that was basically the crux of my education during my PhD. But while I was completing my PhD, I was also a graduate teaching assistant. So for 5 years, I taught Python programming and computer security. So programming and security, and so because of that, I'm familiar with students who are trying, their hands at security for the first time, especially as programmers, because a lot of the times with development, our focus tends to be on getting the functionality correct. We never think about what additional steps could be performed outside of that functional intent. So I'm located here in Chicago, Illinois. Some of my socials are listed there. And currently at Motorola, I work in the product security team as a security architect, basically making sure that our products are secure by design. All right, so I'll let the other two instructors introduce themselves. Krishik, go ahead.
Okay, my name is Krzysiek Minior. I'm from Kraków, Poland. I work in the product security team as well with Pranshu on the business portfolio security professional at this position, and I'm working with various Motorola solutions teams to create, design, and develop the most secure product as possible. I'm also a technical trainer. I have a certification issued by CompTIA organization and Microsoft as well. I have also some other certificate like Microsoft Azure Security Engineer, and I work for Motorola for 18 years. And on various positions, starting from the development through the architecture and also the security. Okay.
All right. Hi, everybody. My name is Paul Soriano, and as I mentioned previously, I'm currently located in Canfield, Ohio, and I think somebody had actually mentioned they're a Buckeye, so which is, there you go. Although I'm currently living in Ohio. That's actually where my wife is from. I'm a Chicago native, so I am a Bears fan, not a Northwestern fan. And if you know where Youngstown is, because if you're a Buckeye fan, then you know that Trussell is here, and everything around Youngstown is all, Ohio Buckeyes or YSU. But I do, so I am from Chicago, and I'm also a security architect at Motorola Solutions. And on the right, you'll see I've worked at various industries, actually in varying capacities as well too. So I'm not just, I hadn't just focused my career on security. I also have experience being a product manager in help desk support, in systems administration, as well as engineering. I also spent 4 years in the Army. So I think because this is Platoon, this is mostly veterans and spouses. So, thank you for everybody for your service or for supporting folks that have served. I only spent 4 years in the Army, 98 to 02 at Fort Bragg, also doing communications as well. I was in a PSYOP unit out at Bragg. So we're all very glad to be able to support all of you in terms of providing this training. And hopefully too, if there are questions as we go along, I know, I saw that the only fort that's like named is Fort Liberty, right? I think we'll take that aside in terms of how forts are named. I'll always know it as Bragg. It just like in Chicago, I will always call it the Sears Tower, never Willis Tower. But yeah, as we go through today's session, like I mentioned, what I will be going through, at least initially, is really the basics of application security, as well as Web 101. And so feel free to stop us at any time for questions. If I don't happen to know the answer, Pranshu and Krishik can also help out too. They're definitely much more technical. I am still technical, but in my career, I kind of went more into management, and even in architecture too, we tend to be a bit more high level, protecting our products and securing our different products at Motorola. So if you want to proceed, Pranshu, I know you're recording this, or you're actually. So the first section that we'll be going through is just the high level basics of application security. And again, feel free to just stop at any time for any of these concepts, because for the next two sections, it's really just setting the foundation of what is application security, some basic security concepts, as well as some basic web concepts that surprisingly, it's really about the basics, just making sure you get that foundation correct. And then we can start to move on to the different sections where you're actually applying some of that knowledge to actual pen testing. So security and engineering. So before, security was a specialized silo. And to be honest, in today's world, when we talk about software, when we talk about technology, security just needs to be built into everything we do. When you think about building a car, there is no separate type of engineer that focuses on the security aspects of a car, things that are not electronic, right? Seat belts or the roll cage, that's all just part of engineering. And so in the same vein, when we talk about software engineering, security just needs to be part of that. And so to be a developer in today's age, security just needs to be part of that. And so that's one of the things that as you kind of go through this process, not looking at security as just a specific discipline, but it needs to be rolled into all of engineering, right? So the tweet here is from Jim Manico. If you're not familiar with him, I don't know if he is one of the founders of OWASP, but definitely very influential, especially if you've ever heard of the OWASP Top 10, which we'll actually talk a little bit more now later on in this presentation. You know, everybody is in security, right? That's just going to be part of what you do as an engineer, right? And in enterprises today, application security teams are now more enablers, enabling developers to write secure code versus you can't push code unless security approves something. So again, just some concepts there to understand that when we talk about security, it's really about security engineering. It's all one discipline. Next slide. Is that you, Pranchu? All right. So when we talk about security, we're talking about typically you're going to hear these three things: confidentiality, integrity, and availability. So any security certification, most people in the security industry, they're usually talking about one of those three areas, and it's called the CIA Triad, right? So those are the kind of key three things and concepts to remember. So confidentiality is whether something is not known to somebody else. So think of, you want messages to be confidential. You don't want somebody to intercept that. Integrity is really that the message itself hasn't been tampered with, so that it hasn't changed. And you want something that's available, right? Something that if you need it, you can get it. So that's kind of, again, just through some concepts, that's kind of what they call the CIA Triad. If you can flip to the next one, Pranchu. So there's a lot, at least with this diagram. Kind of what we want to highlight here is when we talk about different things. So assets, right? I think if you we're all many are veterans here, or if your spouses, right? When we talk about assets, that's the thing that's most important, right? It's what's the thing that we need to protect, right? And so in the middle there, right? Management could be a company. It could even be your own. It could be your own house as well, too, right? So if you think about your house as an example, that's something that you own, and it's also something you want to protect. And when you think of threat actors are people that actually want to do something bad to that, right? So if you have somebody that wants to break into your house, that would be a threat actor. A threat would be like actually, a threat is something that they actually want to do. So if a threat actor wants to actually break into your house, that's a threat, or they want to, damage your house, right? Those are different threats, and the vulnerability is actually what they exploit. So if you leave a window open, that's a vulnerability. Or if you leave your door unlocked, that's a vulnerability. Somebody could walk in, that's a threat. And then that's how, that's what is actually what a risk is, right? You have a risk of somebody breaking into your house because you left the door unlocked, right? And so you have controls such as locking your door so that that vulnerability can't be exploited. So just these high level concepts will kind of set the stage in terms of, later on, when we talk about what's a threat versus a vulnerability, that's really what we're talking about. And we're really talking about controls. Controls is what mitigates and patches those vulnerabilities. So, keeping this in mind in terms of how we think about security, you'll see that this is the language. Just like in the military, we have our own language. This is kind of the security language, different things that are mentioned. All right. So when we talk about what's a threat versus a vulnerability, I started to talk through that, right? So you need to start thinking like an attacker when we talk about security. So at least at Motorola, what we tend to think in terms of your threat-driven defensible architecture, right? We tend to think, well, what can bad guys do to us? Or what can bad guys do to the things that we want to protect, right? But having said that, not everything is important, right? So that's where understanding what we're trying to protect and why we're protecting it is important, even though something may be vulnerable. Is that actually something that we want to protect against? So these are things just to think about, and then understanding that both when you think about a threat and a vulnerability together, that's actually what a risk is. Something has to be important and vulnerable and somebody wants to do something bad to it, that's really what we're talking about, a risk. So actually, yeah, now if you can advance. All right. So we'll do an exercise here for everybody, and we'll actually just think through the different types of threats that, let's say to a bank, right? I mentioned a house, but we'll actually, go through a bank and use that as an example. So, and anybody can talk here, like, what are some example threats that could be to a bank? Like if you were to be a bad guy and you're going to be, a robber, what kinds of things could you do to a bank? And feel free to shout out, like, what are some different threats to a bank?
You can shut down their services so that people can't access them.
That's good. Yeah, that is one threat. Somebody else on the line here, wire fraud. Absolutely. Absolutely, right? So if you shut down services, that's availability, right? And when we go back to the CIA Triad, so the bank no longer has availability, right? Wire fraud. Now you're talking about, stealing money, fake checks, same thing. These are different threats to the bank. Really good. Yeah, these are great examples. Any other threats? Absolutely. Phishing, loss of credibility with customers. That's absolutely a risk to a bank, right? Fake checks is a threat to a bank. It's bad things that can happen, which actually results in loss of credibility. Can you imagine if somebody could write a check against your account and you lose money? Like nobody would ever want to do business with that bank, right? Or if wire fraud is really easy, or walking really with a milli, nice. If you can walk away with money that's not very credible, the bank is going to lose money. It's going to go out of business. And so when you think about those threats and so now let's talk about what are the vulnerabilities? Like how is a bank vulnerable, right? Like they could be vulnerable to wire fraud because they're not putting in proper checks. They're not doing proper the checks and balances in place, right? To make sure that you can't commit wire fraud, right? So to control that, there's different controls. So you have to make sure that before money can be transferred, you have to make sure that there's two people checking to make sure that this makes sense, right? Or you have systems or mechanisms in place to make sure that you can't just take money from somebody else's bank account. They need to authenticate you as, let's say, if you're Ivan or if you're Eric, you are who you say you are, and then we can give you the money, right? So those are different controls and vulnerabilities. So again, just a high level examples when we talk about threats versus vulnerabilities. Threats is really what can happen to the bank, and then is it actually vulnerable? Is there something bad that can happen? The risk there is that you lose credibility, right? So hopefully that makes sense for everybody. And if you can proceed to the next slide. All right, so we will transition over to different types of security assessments. All right, so when we talk about security assessments, there's several things here. I won't read through the entire list, but a couple of key things here when we talk about security assessments. When it comes, I think penetration testing, I don't know if that's, a lot of people probably know what that is, but probably do. Penetration testing is probably one of the more common types of security assessments when it comes to security. Vulnerability scanning is also another one where that type of security assessment, we're really talking about scanning your environment and making sure that there's no vulnerabilities or any security vulnerabilities. So that's another type of security assessment. The main ones that we'll be talking about, at least as it relates to application security, all of them are applicable. Some key things that you want to make sure that you're doing, and you probably have heard, is like threat modeling exercises. So from an activity perspective, threat modeling is really identifying threats and weaknesses early on in the design phase. So when you're building something, you want to make sure that you're thinking through all of the bad things that can actually happen. The same exercise we actually just did with the bank, same thing here with threat modeling. So when you're building an application, you want to just make sure that you understand what are the bad things that can happen to your application. Can somebody authenticate as somebody else? these are types of things that as part of threat modeling exercises that you identify. That's kind of early on in the design phase. The other two, static, dynamic, and software composition analysis, this is really about analyzing code and just making sure, are there any threats or vulnerabilities, or excuse me, not vulnerabilities, not threats, any vulnerabilities in your code. Those types of tools and assessment tools would actually do that assessment and then make sure that that code doesn't have any vulnerabilities in them. So again, when we talk about of all the security assessments, we're actually going to be focusing on penetration testing today. And arguably, I would say it's probably the more fun part of security is if you can break into something. Some people may argue that, but that's definitely going to be the focus of kind of where we're going here today. So any questions so far, or I continue on?
Yes, sir. I have a question. When you say static and dynamic testing, is that kind of the same thing? Like when you're reverse engineering something, and the difference is like between reverse engineering just the code and then also actually checking when the program is running and seeing what's passing through?
Yeah, you've got that. So from a static code analysis, or the first one, static application security testing, it's the code's not running. You're really looking at how the code is actually written and if there's vulnerabilities. So for example, a typical buffer overflows or injection attacks, which we'll actually go into, the code can actually identify it, and you'll have tools that will actually go through that. So if you reverse engineer software, which by the way, Pranshu has his doctorate in that, reverse engineering malware. So feel free to hit him up about that. Done enough reverse engineering, way more than I have. When you get down to the code, you can actually look at the code, and that's actually static SAST, right? You're looking at it not running. That's different than dynamic, and there's different behaviors when you're analyzing code while it's actually running. So it might exhibit behavior that you might not have seen in static code, particularly with business logic types of vulnerabilities, right? Because if the application is doing something that you weren't expecting, it may not come out in the code. So you need to see it actually running in the wild. So Eric, I think you're spot on. Like that's the main difference. You want to see the code before it runs and then while it's running. Both of those are actually different. You'll have different types of vulnerabilities.
Right. And Paul, if I could add an example here. Basically, think about it, because Paul was talking about a bank earlier. Think about it from a perspective of an attacker. So in this case, a threat actor who is looking to steal some money from the bank, right? Your basic Hollywood movie scenario. Well, in this case, there's two approaches that this attacker or this threat actor could take. Number one is, print out the blueprints for the, layout of the bank building, and study that to see if there's a way, what kind of vulnerabilities, if there's doors and windows or underground tunnels that you can dig and get in that way. So that would be the static application security testing, right? The dynamic part of it is when you're staking out the bank outside and looking at the movements around the bank, looking at the environments, looking at what the cops response time would be, how much time do I have? So those kind of things are more on the dynamic side when you're studying not just the bank, but now the environment in which the bank operates. So I just wanted to throw that example in there.
Much appreciated. Yeah, you don't have to say sir, by the way. I work for a living. I was an E5, by the way. So I figured if anybody got that. All right. Next slide, please. All right. So when we talk about penetration testing, as I mentioned, that's kind of what we're going to be focusing on. And you're going to hear a lot of folks say, well, I want a pen test. Like when you go out into corporate, or even in the military too. I mean, I know that when I was in, there was no cybercom, right? Like that was from 98 to 02, it didn't exist. Now we do have cyber warriors that actually focus on this. And even then, hey, I want a pen test. Like what does it actually mean? So on the graph here, you're going to see different types of pen tests, right? That can range from, I'll start from the left, a compliance audit, right? NIST 853, FedRAMP, DOD, right? We need to make sure you're doing these things. Well, that would be more of an audit. And there is value in actually doing audits, but it's not quite the same thing as, let's say, on the lower right-hand side, which is a red team, right? That's actually people that are actively trying to penetrate either an application or a network. that's actually boots on ground. You're actually trying to do something to break in, as opposed to just looking at whatever the controls are that you said you're actually going to put in. And then kind of in the middle there, you've got what's risk reduction, right? You've got different types of penetration tests where, you've got gray box, white box, and black box. And really what we're talking about there is white boxes, the applications, you're given the code as a penetration tester. You're kind of given everything you need to analyze the thing you're about to break into, and then you go ahead and you do that. So that's kind of a white box type of penetration testing. Gray box, you're given some information, but you may not be given all of the information. So for example, we may say, here's a website that you want to break into. We want you to try to break in. We'll give you some credentials. We'll tell you maybe the technology stack it's running, but we're not going to give you, let's say, the application code that's running on there, right? Or any backend stuff. So you have some information, but not enough. Then that's essentially considered a gray box. A black box pen test is literally, go take that objective. That's it. Here you go. Go see if you can break in, whether it's an application, soft mobile application, a website. Honestly, even from a physical security perspective, it could even be break into a bank or break into a military base. That would just be go do that. And that's considered a black box type of testing. We mentioned vulnerability scanning as a pen test, and that's also very confusing. It can be confusing sometimes because people will say, I want a pen test. It's a vulnerability scan. Again, it's, hey, you've got your windows open, your locks really suck, and then you got this thing, whatever. That's just telling you it's scanning it. Actually, red teaming it would be going into the house, looking for, your watches and your money, and then walking out like that. That actually would be red team. There's also code and architecture reviews, and that's what, three of us are typically focused on in that area, is really reviewing what the application is, not actively breaking in, although that can be part of it, but really understanding how the flows work, soup to nuts, and really diving deep. That's also kind of where threat modeling exercises would be, but that's actually where code architecture reviews would be. So again, that is the differences there. I don't know that TV show, Della, but think of it that way. That's exactly what this entire cohort is going to do when it comes to applications. And I'll tell you, you got one of the best here, Krishik, that's actually going to be doing the CTF for tomorrow. You're definitely going to want to prepare for tonight, because that CTFs are a lot of fun, and it's essentially the same thing. So thanks, Della, for that. Next slide, please. All right. So we've been talking about manual penetration testing, right? So a couple of key things here when we talk about pen testing, right? So probably the one thing I do want to highlight is, as you're kind of going through this course, you're going to have be exposed to only kind of the tip of the iceberg in terms of the different tools and things that you can use to actually conduct pen testing. And there's a lot of things that you're going to be able to uncover that most people don't really know when it comes to applications in this case, right, or computer systems. The one thing to make sure is that you only should pen test the things that you have permission to test. I don't think I need to say that. It's kind of like if you see an unlocked door or window open, you probably don't want to open that door or go in somebody's house when you don't have permission. Because even if you have good intentions, you're going to get slammed by the cops. You could be arrested. It's the same thing here. You don't want to pen test on something you don't have permission to test or that you don't own. So you can spin up things in AWS, Azure, your own test labs. Absolutely have fun. We encourage that. Or if you have permissions, like there's lots of resources to actually pen test, but don't ever do this unless you have permission. So knowing how to perform a web application test is important. And the reason why is because you're going to know what attackers are looking for. You're going to know specific vulnerabilities. You can also, and honestly, you'll know how to look at your own applications that way. And that's the intent. So you know how to write better code, right? So understanding even just the basics of pen testing will empower you to actually test things yourself. Make sure that your code is actually running well, and it's secure, right? So those are some of the things that we'll be going through here. And again, I cannot stress enough, don't pen test if you don't have permission.
Yeah, and that's an important point, Paul. Since that was being discussed in the chat, again, I want to highlight there's things we do in the security industry, like picking, locks. And there's actually at security conferences, there's what we call lock picking villages, where they teach you how to pick locks. Now, some of there are easier challenges where it's easier locks to pick, older designs, as you can imagine, and some are harder to pick. But while you're learning that, they emphasize it throughout the class that if you are picking locks, make sure you're picking your own locks. So same principles apply to everything we're discussing today. Any kind of attacks we're going through, just that's why we have CTF challenges, et cetera, where you can practice it in a safe environment, but do not try it against actual web servers unless they happen to have a bug bounty program and you're actually trying to, report a bug and testing for a bug. But even then, there are some rules of engagement, and there's some, you have to understand what scope is allowed and what isn't. So I just wanted to stress that as we're going through this.
Yes, this is everybody's safety brief. So, all right, next slide, please. Okay, I think we've been chatting here for about 35 minutes from the introduction. I don't know if there's folks from actually Code Platoon on here. Is this now a good time for a break, or actually I'll take show of hands, or does everybody want like a 5-minute coffee break? Is that good for everybody? Thumbs up. All right, Roger. All right, so we will take a 5-minute break here and grab coffee, hit the head, latrine, and then we will come back in about 5-6 minutes, and then we'll dive into Web 101. So I'll just put this on mute, and then we'll come right back. All right, thanks.
Are we good to go,
so,
Paul?
yeah, see if we'll let some
I
folks
think
jump
it's,
on here.
yeah.
All right, excellent. And well, welcome back, everybody. All right, so in this next section, yeah, we're going to go into Web Basics 101, right? So, you know, much like we're just kind of giving kind of high-level overview of security concepts and foundational concepts of security, same thing with the web. Always want to make sure that, we're giving some solid, foundation in terms of kind of what are the web basics. And you'd be surprised that, I think I mentioned earlier, you always want to make sure that you know the basics very well. Even over time, people that are very good at kind of what they do, very advanced, it still comes down to the basic principles of how web applications work, how the internet works, right? So that's what we're going to focus here in this kind of segment, is really just kind of going over this. And for some folks, this may be a refresher, or you recently had just learned a lot of these concepts. It's always just good to kind of run through those, because you'll see that you're going to need to build on top of some of these concepts, right? So that's what we're going to be going through. And a lot of the attacks are based off of it's based on attacks rather than underlying security principles, right? So you don't want to just be, I can run scripts and the thing works or it doesn't work, right? Whether it's an attack or an automated tool. You want to make sure that you understand it, so that you're not just doing whack-a-mole. These issues are coming up, but you're not really sure why they're coming up and why they're even an issue. You want to make sure that we understand it, right? If you understand why things work, then you'll know how to defend against them. And that's really kind of the key thing here. And trust us, even for us that are experienced, we're going to mix these things up too. I had to do a refresher myself, because you just tend to forget these things. So we want to make sure that this is front of mind as we kind of go through. Next slide. So one thing that I wanted to bring up, when we talk about foundational knowledge, is when we talk about applications, if you've ever heard of the OSI model, this is just kind of 7 layers of how all technologies work, essentially, right? So you have physical all the way up to the application. And I know that in this course, we're really focused on application development, or an application and software engineering, but it's just useful to kind of refresh on, okay, what are the different layers here when we talk about it, the application, right? You have a website and you have applications, but there's 6 other levels beneath that as you interact with those applications. And I won't run through all of them, but just so that you have this, I don't know if these slides will be sent to you, or at least on the video, you'll just have this as a reference. So whenever we talk about HTTP, www, DNS, FTP, those are all at the highest application layer. That's what we call layer 7. But when we talk about HTTPS and how things are encrypted, right? So, because that's going to be relevant in the next couple slides, those are actually at lower levels, right? Encryption occurs at layer 6. TCP, if you have an IP address and hear those terms, or TCP/IP, those are layers 3 and 4, right? So it's how network traffic actually gets from your computer all the way to Google, right, or Facebook. That's at the application layer. So just know that there are varying layers. So encryption does occur at lower layers than the application, and ultimately the application is what's most important to us as customers, to us as end users. That's really what people see. They're not really going to look at these other layers. So just want to call that out. So again, we're always operating at layer 7, but just there's other layers beneath that. When we talk about security concepts, you can hit any one of these, but we'll focus on the top layer. So in the next one. So with that in mind, when we talk about web technologies, right, 4 key concepts when we're talking about looking at a website. I know this seems very basic, right? But as you saw, HTTP, it's a plain text protocol that ultimately, wherever you go, everything has like a web interface. Even in a car, like looking up stuff, like anything that has a web browser or presents something is going to be HTTP. The key thing there is that HTTP is a plain text protocol, right? It's well defined. There is an organization, an international organization and body that actually defines a lot of these technologies. HTTP is one of them. And it was actually meant to be read just kind of like plain English, right? And it is a protocol, so it's well-defined, it's a standard. And anytime, if you've ever seen TCP, again, which is at the network layer, ports 80 and 443, that's really, anytime you see those ports, typically you're going to be looking at HTTP, right? So again, it's plain text. You'll see why that's important here as we go into other security concepts and techniques. It's plain text. You can see it. That's kind of the first thing. So I actually forgot what HTTP is. Hypertext Transport Protocol, I think, is HTTP. No. HTML is the second kind of key concept here from a web technology perspective. So HTML is a markup language. It's not a programming language, but it actually describes how the browsers, or it describes to the browser how it actually renders a page. So you'll see HTML on the right-hand picture here. It's describing what should be shown on your web page. So if you've got another screen open or something, if you go to Chrome or Safari or any browser and you go to Google or CNN.com or whatever page, it's working on HTTP, and HTML is actually what's rendering on your browser to actually show all of the different buttons and things like that. That's HTML. And it is, again, can be readable by a human. It just renders stuff on there, but it's not like, like JavaScript, which we'll actually get to in a second. Cascading style sheets, CSS, is actually some of the metadata that's related to HTML and actually tells the browser how to display things. And you can see it's what types of colors, where should this thing be within a page. Thank you, Franchi. That might be one thing, because I'm not sharing, that if there are questions about this, Franchi, we can actually dive into right-clicking and viewing source or inspecting different objects on a page to actually see what that looks like. And maybe we might do that here in a second. The last concept here is actually the document object model. So if you ever hear of DOM, that's actually the browser parsing the HTML and CSS. It's the browser parsing that into the DOM, and it's ultimately what's gets displayed to you, right? So when you look at a web page, just like in the picture here, the DOM is actually what contextualizes all of that into a page. And so these are key concepts as we start to look into penetration testing, different things that you'll see, right, as it relates to web technologies.
Yep, and DOM is something which confuses folks at times, because the confusion is usually how is it different from HTML, because a lot of the times folks never see DOM. You can still see HTML when you view source, but unless you're inspecting a page and inspecting elements on the page, you will not see the DOM. So let us know if the concept of a DOM is not clear. It's something that you should be clear on moving forward, especially as we're discussing web attacks, because some of the attacks we'll discuss in the later part are based on the DOM. So
actually, do you want to just, do you have a screen, if you can just right click and actually show the view source, we can actually show them.
Right. So I'm sharing
okay.
specific screen, but let me see if I can actually do it right on this page that I'm sharing. I think you can.
Oh no, I think it's you might have to
because
open up
this is. There you go.
There you go.
Are you talking about the viewing the page source?
Oh,
can you still see the page source, or are you still seeing the slides?
No, I can see the page source, but I think we're getting feedback here. Okay, yeah, single SPAs, root. Okay, so if they're familiar with DOM, that's going to be the key thing. Okay.
Okay. All right. That's good.
Yeah.
That's great.
Perfect. Then. Okay. No, thanks for the feedback. I just wanted to make sure that we're going through that. All right. So when we talk about then JavaScript, right? I think I'm not sure. Is everybody what kind of applications is everybody writing? Is it React? Is it just pure JavaScript, TypeScript? If anybody can shout that out. React. Okay. Yeah. React.js. Okay. Yeah. So when we talk about React, it's still it's and Django. Okay. Postgres. So same thing here, right? JavaScript really is the main engine that's going to drive everything on a page, and it's the same thing with React and most of these languages, right? These are actually complete languages. that, browsers have their own JS engines that actually loads and executes everything on there. JavaScript also has full read and write control of a DOM. And again, that's going to be key, when we talk about, executing scripts and taking over and performing different types of attacks, right? It also has full access to the browser storage, which we'll get into here in a second. So just know that JavaScript, a lot of attacks and different things that you read and see, it's going to be JavaScript that's actually rendering these pages. I don't think anybody really writes HTML by hand anymore, CSS. Back in the day, I have web pages that are probably not still around anymore, written in HTML and CSS, very, very simple. 25 years later, you have JavaScript as these languages, much more powerful. And they do talk to APIs as well too. So, the functionality is really, really, really expanded with JavaScript. The browser does execute JavaScript within the sandbox. So browsers have also come a long way too to kind of limit the amount of bad things that can happen, because of things like JavaScript, which are so powerful, for a browser. Actually, if you scroll to the next screen, please.
Before you move on, Paul, I just wanted to ask the class if anybody has heard of a cryptojacking attack. Nobody in the chat?
I've heard it, but I'm not familiar with it.
Right. So cryptojacking is basically when, an attacker is using your computer to steal cryptocurrencies or to mine cryptocurrencies, right? So they became prevalent in about 2017-18 when the Bitcoin and other cryptocurrency value shot up. Now, my point in bringing this up is they actually introduced JavaScript on malicious pages. So if you go to some of these malicious pages, they're showing you the content that you think you want to see, but in the background, they're also mining, using your computer's resources to make the attacker money. So it's basically they have an address, and they're mining on behalf of that address to basically generate money for that address, but in your web browser because you happen to be on the page. So JavaScript is so powerful as a programming language. I just want everybody to understand that JavaScript is a very powerful programming language. It's not just web; it can do a lot of other things, and there's a lot of malicious use cases for it that unfortunately attackers have discovered. Cryptojacking being one of them. Another one was somebody wrote a ransomware, which was actually a full-blown JavaScript-based ransomware that would encrypt system files, based on the if you were infected with it. So just to kind of highlight how important it is to think about JavaScript.
Yeah, no, absolutely. And that's where, when we talk about APIs, we'll actually get into, I think you got to go back one slide, Pranchu. There you go, HTTP basics. Yeah, so we'll actually cover that because there's this concept called AJAX programming. As Pranchu is mentioning, like JavaScript can actually interact with the underlying browser and applications that's sitting on the host as well too, right? So those are some of the things that we'll touch on here as well. So HTTP basics, again, sounds like that the class here is a bit familiar. So, when we talk about HTTP, again, the key things here is that it is plain text, and you'll see here that, some simple tools such as Netcat, if you're familiar with it, it's command line driven, very simple tool. You can use Netcat to basically query Google and then just get a response. And that's really using HTTP. And you'll notice here, 80 is actually the port that's actually being used. So for Apple, from a viruses, yes. I mean, Apple is still, that's not always the case. I think Della asked a question that she's heard that Apple computers are harder to get viruses and attacks. Is this still true, or as attacks have gotten more advanced? I would say that more advanced malware is making its way to Apple, and particularly because it's an economics thing. More people are using Apple computers. In fact, that's actually what we have as an option for us at Motorola Solutions. We have Apple computers. So as more people use Apple computers, a lot of people are starting to develop malware more so on there. So So yeah, I mean, it's still not as prevalent as, let's say, Windows. Trust me, Windows is still Swiss cheese compared to other operating systems like Linux and Mac. But certainly Apple is starting to get into the limelight in terms of different malware attacks. So it's a good question. So on kind of HTTP basics, the other key thing is beyond just HTTP being plain text, HTTP is also stateless. That's one key thing here, is that every request that is sent out for HTTP on port 80 or 443, it's just one request. The next request you send has no concept of what the previous request was. So every single one of those things are very independent, right? So they have to stand alone and include everything in that request. And so you'll see later here that the concepts of cookies actually come in to actually maintain state, which isn't perfect, and that's actually because of when HTTP was developed, it was meant to be stateless so that it could, it's it's loosely coupled. So it doesn't have to rely on the previous requests. You can just send HTTP requests and it kind of stands on its own. So again, just key things to know about HTTP. Next slide, please. All right, so when it comes to encoding, key thing here is that even though HTTP is a plain text protocol, there are certain characters that does need to be encoded. So for example, carriage return or line feed, or a new line, those are characters that just aren't interpreted by like a character. They're kind of blank. So you need to represent, if you want a return or if you want a space, you actually need to encode those so that HTTP, or so that web browsers can actually understand that. So the concept of encoding is something that web browsers can do, so that if you want to send, again, a new line like here, it's going to mean something different to HTTP. So if you want to send a literal new line character, you have to encode that. And here's all the different types of encoding. You have HTML encoding, base64, and some others. Key thing here is that encoding definitely does not mean encrypting. Like, it's definitely not for anything security related. It is simply to either compress data or to actually send literal characters. It's really meant from a functional perspective versus an actual security perspective. So anytime you see, oh, we encrypt passwords with base64, like, that's totally false, right? Like, you do not use encoding for security. It is simply just to change formats or to compress things by using a different format. So just knowing that encoding does occur, that's going to be helpful, especially later on in the practical sessions. Encoding is one of those things you want to keep in mind, that, oh, I want to send a character, I want to send some text. Let me think about how this thing is encoded, right? Or how it's actually reading characters. Maybe I encode it in something else and I can pass something through a security mechanism. So keep that in mind. Next slide, please. All right, so HTTP session management. So kind of the key thing, again, it's stateless. The previous, you send a HTTP request, or it's not going to know the previous HTTP requests that were sent. So servers don't know whatever you're sending next. It has to accept every single request, and it just simply processes them without any context to others. So in the early 90s, this concept of cookies were invented so that whenever you send a session, you now have a cookie that's written on the person's client side on their browser, or on their system, to actually then maintain sessions. So you're not having to send all of that information in the HTTP request. You can say, oh yeah, refer to this cookie, and it's got information in there so you can recall some of the other stuff that I sent in the past, right? So it's a way to do HTTP session management, and that's what was invented in the 90s, is this concept called a cookie. So, and if you know about tracking and advertising and all of that, that's cookies is absolutely what's being used. To even today, cookies are still being used. Unfortunately, it's something in the past. If we had to do this over again, you probably wouldn't have cookies. You'd probably invent something else, and we'll go into that here in a little bit. Next slide. Yeah, HTTP. Oh, go ahead.
Before we progress to the next slide, Paul, I just kind of wanted to highlight. Does anybody know what that where that is from? This made a lot of people very, let me see, very angry, and has been widely regarded as a bad move. Does anybody know where that's from? A Hitchhiker's Guide to the Galaxy. It's a good book if you haven't read it. It's a funny book that actually is very popular. All right, moving on. Sorry, Paul.
No, you know what? I probably have to read that. Hitchhiker's Guide to the Galaxy, or
yeah,
butchering it. Yeah. And I think we're being recorded too. That's fantastic. All right. Making HTTP requests. So there's two ways that browsers make HTTP requests, and they are distinct. And this actually relates back to what Pranshu had mentioned too about cryptojacking. And so this is where we're going to kind of go into that. So the traditional way for browsers to actually load makes HTTP requests is kind of what we say like the traditional way, right? Browser's going to load a resource, something changes on the browser. You click a button, right? Or you automatically load the page. You'll see here, you start downloading .css file so it knows how to render, the proper colors and buttons and everything for the page. JavaScript file so that I can actually do something to the page, maybe put up a screen or make something, whatever on there. Or there's an event. So if you're on google.com and let's say you want to submit, a form, or you actually want to search for something, you click and then something changes on the screen, right? This is the traditional way of your browser making an HTTP request, right? These are what we call like HTML requests. It's something that on the HTML elements that is actually enforcing an HTTP request from your browser that on your computer that actually makes that request to a web server, right? So that's kind of the first distinct way that HTTP requests are practically made from a web browser. On the next screen, you'll see that the second way is kind of the JavaScript way, right? And so this is where now, instead of a person that's behind the browser either doing something on the screen or the HTML page actually rendering on your browser, JavaScript is actually doing that, right? So when JavaScript calls the browser API, it's XML HTTP request, right? Or XHR, or it's a fetch API on newer browsers, right? The key thing here is that JavaScript makes requests and read responses silently in the background. So again, going back to the crypto mining or cryptojacking example that Pranshu made earlier, this is what JavaScript is doing. And that's the concept of AJAX programming, right? So it's really it's asynchronous JavaScript and XML working in the background. If you go to Google Mail, it's the exact same thing it's the exact same thing that's occurring into the background, right? It's actually loading stuff in the background and you don't have to do anything. And these are AJAX requests, right? They run in the background, it's invisible. And so these are the two different ways that HTTP requests are being made. One is from a user, the other one is actually just silent. And you'll see that that's how, when we talk about attacks, it's really the second way that attacks are being done is actually the JavaScript way of making HTTP requests. All right, next slide. All right, so we talk about cookies, right? Cookies, those are identifiers, again, used with, at least back in the 90s, right, with HTTP session management. There's other ways to do that now, but still cookies are still used as identifiers, right? Actually, I want to say that, cookies were invented, but I mean, advertisers and advertising companies have been using that for years. There's like definitely other ways for advertisers to actually fingerprint who you are as a person, and then, target you with some ads. And browsers are more than happy to send matching cookies anytime they get a request, right? So if you go to a web page and you're sending an HTTP request, it will just send any cookies that match. Like that's just how it works. Now, later, cookies have some flags that actually improve the security. So again, you've got HTTP only, right? So JavaScript, it doesn't let it read or write any of the values, secure and same site. And so we'll actually get into what we mean by same site. It's a newer flag. When we talk about same origin policy, that cookies can only be used in that sense. So questions, comments, concerns so far? I feel like I'm droning on, but I want to make sure that I could probably talk too fast. So any questions or comments? I will take silence as you already know this. Perfect. All right, next slide. All right, so we have the concept of cookies. These are files and text files that are actually written on the browser. But besides that, there's also the concept of storage APIs. And so these are things that are local to the browser that JavaScript can actually use. Actually, in React, you can use it as well too. Actually, any language, right? That can actually leverage the storage that's on a browser. So you've got local and you've got session storage. And kind of as the names denote, for local storage, these are things that are going to persist a little bit longer. That's available to the origin. We'll get into that here in a second. So even if you close that session or you close that web page, that local storage, that cookie is still going to be there. You can still access it. Session storage is only available to that current window. So if you've ever logged into like USAA.com or any other banking page, you might see something that says, hey, you've logged out, please close your browser, or close that particular window. By closing that window, you actually clear session storage, any cookies or any information in that session storage. By closing that window, things that are written in local storage, kind of persist. That is a finicky thing in my experience when you talk about authentication, logging into websites or single sign-on, if you've heard of that. Where you store information matters. You want to typically store it in session and then close the window to manage those different types of information. That's going to be really important. So just knowing that those two are available as we build applications, just know the difference between those two. So while cookies can be protected from JavaScript, these two storages are always available. That's why it's important to know the difference. If you store something on storage, JavaScript will always get access to it. So try not to store very sensitive stuff in that storage, like ever, because that's not a good thing. Somebody gonna bring some question? Oh, okay. So one thing to keep note too on the bottom here. So cookies are scoped to the domain, so like example.com, but only available to JavaScript within that origin. So, and browser storage is isolated entirely by the origin. So the local and session storage is isolated only by the origin itself, which actually we're going to dive into here in a second, actually in the next slide, and why that matters. So if you can flip to the next slide, please. All right. So from a security perspective, one of the concepts that was developed later on was called the same origin policy. Because browsers, like, it's very bad, obviously, to execute arbitrary JavaScript. And so using same origin policy basically restricts how information information on the local or the session storage can actually be used only if something is actually coming from the same origin. So obviously you only want to make sure that the site you're going to, let's say you're going to USAA.com, you want to make sure that JavaScript, is only executing on USAA.com and some other script isn't doing stuff to your bank account, right? That's the kind of stuff that same origin policy does protect against, right? And so there's two main security boundaries for a browser, right? There's the sandboxing, which we touched on earlier, where JavaScript should never escape the browser and then access the underlying host itself, right? Meaning JavaScript can't just go, turn off your Wi-Fi. It should never be able to do that. Your host controls that with the operating system. Should never do that from a web browser. So that's what the sandboxing concept. For same origin policy, it also says that JavaScript can only see and access data from associated with the origin it was loaded from. So if it loaded it information from USA.com, JavaScript from chase.com shouldn't be able to access it, or, evilbrowser.com to actually access that data because it didn't come from that same origin. So you can see it's just really trying to put security boundaries around what data is used and where you can actually, and what JavaScript can actually use it from, right? It limits that. So on the next slide, you will see where, okay. So if we didn't have same origin policy, as you can see as an example, any site you visit could load malicious JavaScript and interact with the sites that you're actually logged into. So again, if you're logged into USA.com and you go to some malicious web page, that page can run JavaScript and do whatever it wants on the other pages you have open, or on Facebook, right? It could post things that you don't want or delete things that you don't want, right? Make a request to Amazon to order something, that you, maybe a new MacBook if you wanted to, but it would go to the other person. So, and again, when you think about the concept, like the example here is XML HTTP request, you would have no idea that that's running without same origin policy. You just simply go to that web page, and like in Pranchu's example, cryptojacking, it's just going to occur and you'd have no idea it was running. So again, that's why the same origin policy, that concept is just important when we talk about software development and web application development, to just make sure that you're using those, those things properly and that you're actually leveraging that as you build your applications. All right, next slide, please. Okay, so when we talk about origins, we talked about cookies are scoped to domains, but origins just have a stricter definition, right? So we'll run through an example here. So let's say that JavaScript is loaded, right? The origin is going to be HTTPS, www.example.com homepage. Which one of the following examples here would you think would actually be the same origin? And again, remember, origins have a stricter definition. So any guesses from the class here? You can post it on the chat as well too, or you can shout it out. All right, I see Michael says B. Any other guesses? A? All right. Michael, let's see.
A different Michael says A.
What's that? Yeah, different Michael says. Oh, hey, hopefully everything's okay for my Dahlia. I know that that's about to hit over there. So if a DC, it's from that. Okay, no worries. Just be safe out there, man. All right, if there's no other guesses, any others before we, because as soon as Prancher hits it, it's going to give you the answer. All right. There you go. Nice. All right. For those that answered B, either in your head or if you announce it here, that is correct. So there's three things when we talk about origins, right? It's the scheme, or think of the protocol. In this case, it's HTTPS, which the S there stands for secure, and that's 443. And you can see the second is also the port. So the scheme has to match, the port has to match. And so, C is not going to be a good example here, right? Because that is doesn't have HTTPS, and then the host does matter. So here, A and D, right, have different, doesn't have www here, and then for E, it's a different port. So again, it's very important to know the origin, and so if things come from the origin, then JavaScript can use and execute anything that comes from that origin, right? So that's really the key thing here. All right, next slide, please. All right. So again, this is just another example, what I just mentioned. So JavaScript is loaded. So how is it loaded? It's anything that comes from a server response. So if the server responds with, hey, here's the things that you can download, it will actually execute it. So even in something like this, right, even though it comes from a different server, because the origin it was taken from a server that replied with it, it will actually still load it, right? So those are some of the key things when we talk about loaded from an origin. It really is it in the same domain, and did it come from that origin? If so, it can actually execute it. Next slide. All right, so from a web application security perspective, again, we're kind of starting to wrap up here in terms of kind of the Web Basics 101. Key things here is just always keeping in mind what are the foundations of kind of web applications in general when it comes to like HTTP, HTML, and JavaScript. And from a security perspective, usually the security concerns, like when we talk about web applications, you're going to see two broad things. You're going to see there's a client side types of attacks and security concerns. That's really users. So actually where you're sitting today, you're actually watching this live. If you have a web browser, that's going to be client side attacks. And that's actually targeting users, or you have server side. You can also think of it as front end and back end. So those are the two broad types of security categories when we talk about web applications. So again, as developers and software engineers, you're already ahead of most security folks. Like, there's a lot of security folks, but I can't tell you enough, I can't stress enough, that a lot of security folks may not know the basics of web applications or the foundational aspects of the thing they're trying to secure. So you got to know the thing that you're trying to break into or secure to really understand the security of it. So that's those are just some key things when we talk about web application security. So I'll transition here for about a minute or so when we talk about OWASP, and then we'll get into a break here before the next section. So has anybody heard of OWASP before? And again, you could put that on the chat, or you can shout it out too. Okay. Oh, so OWASP, no, which is good. So OWASP is the Open Web Application Security Project. And what that is, it's a non-for-profit foundation and organization that actually promotes web application security. So for this group here, definitely learning and taking time to learn more about OWASP and all of the different resources that they have is really going to be beneficial for you. So there's like, it's a non-for-profit foundation. There's chapters all across the world. So wherever you're sitting, there might be an OWASP chapter that you may want to participate. And of course, they've got a lot of free resources and training. And I would suggest and highly recommend that as you further your career as web developers or software engineers, that OWASP is something that you dig into. And when in doubt, always go to OWASP. They have a lot of resources for anything application related. And we'll actually dive into what's called the OWASP Top 10 here on the next slide. So if you're not familiar with the OWASP Top 10, it's really the top 10 web application security risks that comes out about every 4 years. So the latest one, at least that's out right now, is 2021. So one is going to be coming out here the next year or so. The thing to keep in mind is that it's not an exhaustive list. It's definitely not a standard either, right? So it's not like some standard that says these are the only risks that there are. It's really kind of a practical type of thing where here are the top 10 security risks based off of research, analysis, and experience from the curators that recommends these are the things to watch out for, right? And they also publish cheat sheets and remediation guides for any one of those 10 vulnerabilities. So if you can skip to the next slide, please. So as I mentioned, they update it every 4 years. So in previous courses, for this course, which was previous to 2021, 2017 version was put out. In 2021, there was some consolidation and some movement in terms of the different attacks. Again, OWASP, this isn't a standard. It's kind of what they see out in the wild and in the industry. So you'll see here the top 10, and we won't dive into this. I'll leave that as an exercise for the group here tonight. Take a look and kind of just dive a little bit more into the top 10 vulnerabilities. The two that I've got starred here are going to be the focus for later on sessions from Pranshu as well as Krishik, which is injection, which from 2017, cross-site scripting, if you've heard of that, and hopefully you have, those are kind of old school attacks, but it relates to injection attacks and now consolidated into just injection attacks. So that's going to be one aspect that will be, Pranshu will dive into in a more detail. Cross-site request forgery has kind of dropped out, but it's still relevant today and will into the future. There is a concept of server-side request forgery, which started to gain popularity. It's on the top 10 list. But that's another thing that Prancha will actually dive into. So again, those are starred for reference. And that will do it actually for me. So before I hand off, is there any other questions, comments, concerns from the group before I hand off? All right. Well, I will hand it over. Actually, before we dive into, again, we probably want to take probably 10-minute break. Does that work for everybody? I don't know if hands up or
Yeah,
Roger?
I got a thumbs up in the chat.
Excellent.
Yes. All right. So sounds good. We'll take 10 minutes then. It's for Chicago, for me here, it's 10:20, about 10:20. So we'll meet back at 30. So in about 10 minutes. All right.
Sounds
See you.
good. Thanks, everyone. See you.
All right. It's like it's 10:30 here my time, so we should get started here. Let me see. Is everyone back? I see Eric's back.
Yeah, folks are starting to file back in.
All right. Sounds good. There's a question from Benjamin. Transfer host back to me. Yes, we can do that. So after the presentation is completed, I'll transfer host back to you. All right. Okay, so let's get started. Everybody's back. Welcome back, everybody. So my name is Pranshu, and I'll be doing the rest of this of today's session. So this is basically section 2, and in section 2, what we want to do is web apps manual testing. So this will we'll start to kind of dip our toes into the world of what the attackers do or how the attackers see the world. So throughout this this course that you've been doing with Platoon, you've learned how to build a web application, and a lot of the times when we're developers, when we're wearing our developer hats, we're focusing on functionality, right? So it's only natural for us to focus on getting the application to do what we want it to do. But while we're focusing on that, we sometimes don't think about what will the application do that we're not aware of. And that's where the attackers make their bread and butter. It's basically making sure that they test your application under unexpected inputs, under unexpected conditions, and then seeing what comes out. So that's the second part of this session. One thing I forgot to mention in the beginning was thanks to Ronnie Flathers for the slides. We all love presenting the material here and presenting the course here and talking to you, of course. But the previous instructor for this session created the slides. And so sometimes somewhere you'll see his name on some of the screenshots. And so just wanted to make sure that you're aware of what that is. All right, so let's talk about HTTP, right? So Paul has already kind of laid the groundwork for us. I want to focus more on the browser server behavior, right? So you know the theory behind the scenes, and Paul has taken you through a little bit of a refresher on that. But what happens when we make a web request? It's basically a client and a server talking to each other, right? So modern web apps, they have got all sorts of things going on. You talking about, we discussed what web technologies you guys are using, and you mentioned, Django, React, Angular, all those kind of things. That's great, but at the end of the day, it's just a client talking to a server, right? So think about it in terms of request and response, right? If you think about it in terms of request and response, you'll see that there's an opportunity for us as an application security tester or an attacker to intercept the requests. And why are we talking about intercepting requests? Because if we can intercept the requests in the middle, we can modify the content. And we'll talk a little bit more about this. So testing web applications is always just a matter of reading, sending, and modifying HTTP, right? So when you're on google.com, what happens is your browser, in this case, I've shown Chromium, because that's the browser you'll see tomorrow in Burp Suite, which is the proxy that we'll be using to perform a lot of these attacks, or a lot of these tests. So when your browser makes a request to the web server, the browser is usually saying something like get/index.html, HTTP 1.1. So what that means is, give me your main index.html page, and then the server responds with, okay, 200, meaning you've probably come across HTTP error code, so 200 is okay. Yeah, your request is valid. That web page looks good. I've got that web page. Here's the web page. And when it's sending you the web page, what happens under the hood is basically it's got that HTML that it's trying to send you in chunks, and on your browser that HTML assembles, and browser has instructions to how to put that on your screen in a nice, pretty format. And the pretty is where the CSS comes into the picture. And so all of that is happening, right? Now the browser could also go, well, I see that you're also talking about this JavaScript that you call main.js. Can you also send me that thing? Send me the JavaScript. And the server responds that, okay, that's valid. Let me send you the JavaScript. Same goes for any images that you may have on the web page and so on. So this is the request response scenario between client and server, or your browser and the server. So now what can we do here? As an attacker, we're interested in crafting HTTP, right? So a normal scenario would be your browser making nice requests to the server. The server knows what to do with those requests and send a nice response back. But manually testing web apps is all about sending custom HTTP. And in that custom lies the opportunity to do some manipulation and sending unexpected input. So how do we do that? Well, we could just open a TCP connection and start writing HTTP manually. Like if you're an elite hacker, then you can try doing that, because there's a lot of, it's not even about being elite. It's more about, there's a lot of legwork required, because you have to write these requests, manually from scratch, and it's just not very time. It just wastes a lot of time. So the better way is to use a proxy. And why is that? Because then what happens is the proxy sits between the browser and the server. All right. So when you're saying get index.html, your browser, instead of going directly to the server, you have configured it to go via the proxy to the server. So now the proxy sits in the middle and is seeing all the traffic pass through it. And because it's seeing all the traffic pass through it, it has a default intercept option, which if you turn that on, and we'll take you through Burp Suite tomorrow. But basically the point is that you can intercept, you can pause the request. So as soon as you say on your browser, www.google.com, the request will transparently be sent to the server, but now you've turned on the proxy. Now the request is paused. You can see it in the proxy, all of the underlying details, and there you can start manipulating it. And then when you're ready, you explicitly hit send on the proxy, and then the request is forwarded to the server. So when the server sends the response, again, it will send the response to the proxy will see the response and then send it back to the browser. So now you see we have this option to manipulate things in the middle. So that's our objective. All right. So Burp Suite and OS Zap are two security-focused web proxies. So I've mentioned Burp Suite a couple of times before the slide. Burp Suite is an industry standard tool. It's actually a company called Portswigger that creates this tool for web application testers, and there's a community version of the tool that's free to use, so that's what we will be using. And then there is a paid commercial version of the tool as well. If you're a big, large corporation, then you can buy the paid version. So it has a lot of different things going on. It's a complete suite of all kinds of, it's a Swiss Army knife of web application security, they call it, because they've got a lot of different kinds of tools, tabs. When you first start it up tomorrow, you'll see that, you can get lost there in all the details. However, we'll go through some of the scenarios, so we'll make it easier for you to get started. So that's one of the tools that you should be aware of. The other one is OS Zap. Now that one is open source. Paul Krishik, that one is open source, right? OS Zap. I know it's not paid, but is it also open source?
Yes. I believe so.
Okay. All right.
Correct.
So that basically has the same job as Burp Suite. It will intercept. It will sit in between your browser and intercept the requests going in and out, and then you have the choice of performing some attacks, some tests, some static, dynamic application security testing, as we were discussing earlier. Attackers, if you're a malicious hacker, then you will use it to find the same vulnerabilities that a tester is looking to find. However, a tester is going to report the vulnerabilities to the respective party, but an attacker will actually look to take advantage of those vulnerabilities that they've discovered using this tool, and will exploit them in the wild. So that's the main difference. But so for our purposes, by the way, this icon in the middle, that's a burp suite icon, just so everybody's clear on that. OS app has a different icon. So proxies let us view, pause, and modify HTTP traffic in transit. So the majority of the web attacks that you'll see, they're based on sending unexpected HTTP requests to a server, and the server doesn't handle them properly. And we'll see examples of that. So you have a good request being initiated from the browser because you just asked for, let's say yourbank.com, right? And the request is going to the bank.com, but you intercepted the request, and in one of their web forms, you did some manipulation. You're trying some injection attacks, and we'll show some examples in a few minutes here. But then you modified it from a good request to a bad request, and this bad request is now going to the server, and the server is going to try to process this bad request. And a lot of the times, web applications are not written. If they're not written well, they will either throw out an error message, or worse, they will become a conduit in a lot of the incoming attacks against unsuspecting victims. So how this happens, we'll see in a moment. But these WTF responses, where the web server does not know what to do with this bad request, is what the security testers live for. Because if you can get a server or an application to behave unexpectedly, then that's an opportunity for an attacker to start digging further and using that to their advantage. All right, so at this point, we've been talking about, up to this point, we've been talking about HTTP. All right, that's great. HTTP is unencrypted traffic. So your bank.com is not likely to have an HTTP link. So if you go to any of the major banks, Chase, Bank of America, you will not see HTTP, right? You'll always see HTTPS. And HTTPS means SSL, TLS, which basically means your connection is end-to-end encrypted. What that means is there's military-grade encryption, we call it. These are standard encryption algorithms like AES, RSA, et cetera, that are being used to secure that channel so that nobody in the middle can read the traffic in plain text, right? So it's all encrypted. This is why when you go to gmail.com and you type your username and password, although it's being broadcasted over the internet, nobody can actually read your username and password if they're sniffing the traffic, right? Why? Because it's end-to-end encrypted. So they can sniff the packets all they want, but those packets are encrypted. So that means they won't be able to tell what your username and password is. So how does that work for a proxy? Because, well, we're talking about intercepting the traffic and manipulating it. So how are we able to read these requests in a proxy? Well, we are intercepting and tampering with our own browser and traffic. So we can configure the browser and the proxy to decrypt for us. What this means is, it is, as far as the server is concerned, it is still a valid HTTPS connection, end-to-end encrypted, except we're modifying the definition of the other end. The other end, instead of being the browser, is now that proxy on your own system, right? So you can't do that to somebody else. So if I'm sitting here and I can't configure my burp suite to intercept your requests on your system right now. And that is because I don't have control over your system. So basically, you can do it on your own system, and you can say, well, hey, it's end-to-end encrypted, but between the server and the burp suite proxy, and then so that's where it unlocks it at the proxy level and then sends the request to us. So that's why we're able to see it in plain text. So I'll take a pause here and see if there's any questions. Any questions about the concept of proxies intercepting HTTP and or HTTPS traffic? Because this is where we'll start to do our manipulation. So any questions? You have A lot of responses in the chat. Let's see. Yeah. Oh, you don't want military grade?
Yeah, I was gonna say.
Here in the
Keeping-
civilian world, we consider that like the top quality, right?
Yeah, then when you go in, yeah, when you're in, then you're like, well, you know.
Yeah. Okay.
I have a question. Is SSL TLS, is that considered enough to encrypt like passwords? Should it be encrypted? Like, should there be other levels of encryption for passwords?
Not really. Most of the time, if you're talking about, so it depends. Are you talking about securing your passwords in transit, or are you talking about securing your password while at rest? So whenever we're talking about encryption and cryptography, we're talking about securing data in two different formats. One is when it's flying over the network, going from point A to point B, and that's called securing in transit. And then one is when, let's say, you're storing a password on your system because you have let's say a password manager, and that is storing something on disk, your list of passwords. Well, that is encryption at rest. So if you're talking about encryption in transit, the SSL TLS is more than sufficient because it, like I said, it uses standard NIST algorithms like AES, and NIST is a standard government body that's make sure that basically there's very intelligent cryptographers and cryptanalysts who are evaluating from around the world if the encryption algorithms are as secure as we want it to be. So we use those encryption algorithms while the data is flying in transit. And so that is good enough for securing your password. If you're paranoid, or if you want to take the extra step, and sometimes there's some other use cases that I don't want to get into right now, but if you have some extra security that you need while in transit, then on top of that, you can also use a VPN. So what the VPN will do is you already have the end-to-end encryption for Gmail or for whatever email that you're using. But on top of that, the VPN creates its own VPN tunnel and further encrypts the data. Now use a trusted VPN, but even if you don't, the data is still on, end-to-end encrypted with the Gmail server. At rest, you have to take some extra steps. So if you're using a password manager or something, make sure it's using standard AES kind of algorithms to lock the data and is encrypting at rest. Does that answer your question? It's a long way to provide you an answer, but I just wanted to make sure you understand the difference between encryption in transit and encryption at rest.
Yes, I think so. A specific case, for instance, for this question would be putting in you put in your password as plain text, and then just without encrypting it, client side, sending it via SSL to TLS, or that's the only way that it's encrypted client side, and that's perfectly secure.
So you're saying, yeah, that's perfectly secure, as in you're talking about while sending the password, if it's just a TLS connection, is that good enough? Is that what you're asking?
Yes.
Yeah, that's fine. If your web application is designed to, or your web server is basically communicating over an SSL TLS, which is what basically is HTTPS connection, then that's good enough for securing secrets while in transit.
Okay, thank you.
Yeah. All right, let's see any other questions in the chat. I'm not seeing anything. All right, so I'm assuming at this point everybody's clear with the concept of a proxy sitting between your browser and the server, giving you a chance to pause any requests and allowing you a chance to manipulate those before they're sent out to the server. All right, so now basically all kinds of web application attacks, you can all boil it down to bad input, right? When you're building a web application, and as you become, as you start your career, or as you get better at security, maybe you already started your career and you're looking to get better with security, always think about the input that your application is accepting, because that input, think of it as doors and windows in a house. Otherwise it would be just walls and it would be all good, but that input that you're taking from the user is doors and windows, which allows people to get into secure areas of your application, which they shouldn't have access to. So the golden rule of web security or security in general, really, is all input is evil unless proven otherwise. So distrust all user input. Assume that user is going to try to provide you bad input unless there's an explicit reason to trust it. So what I mean by that is, think about if you have a simple web application that is, you're asking for a user's name, phone number, and address. Well, a name usually does not have special characters. Well, I should take that back because of what Elon Musk named his son, right? I mean, those special characters. Yeah, so we can no longer assume that. But let's talk about phone numbers, right? Phone numbers basically are just numbers and not special characters and not characters. So when you have your web application expecting a phone number, you're not expecting special characters. You're not expecting basically alphabets. So you will write rules to make sure that if a user enters anything outside of what is expected in the phone number field, it will be rejected by the server. So go by the assumption that the user will try to enter something unexpected, so that when they do, your web server is equipped to gracefully handle those bad requests or that bad input. And by gracefully handle, I mean, if you don't have explicit instructions for the web server, it does not know what to do with all of a sudden. Now it's trying to, it's trying to, let's say, perform some, you're expecting a numerical input, let's say the number of orders that somebody wants to generate on a web store. And instead of actually expecting a number like 2, 3, 4, 5, what's the quantity that you want, the user is putting in special characters or alphabets. Now the web server is trying to apply mathematical functions on top of this input because it thinks it's a numerical number, so twice, like 2 multiplied by whatever the cost of the item is, and it's trying to compute your total cost, but it will crash because it does not know how to multiply an alphabet with a number. So these are the kind of scenarios you should already be thinking in your head while you're writing or designing your application, because these will occur, and your server needs to gracefully handle these kind of invalid or unexpected inputs. Yeah, and Eric, you're right. It's input sanitization. You basically make sure that whatever the user is inputting, it's sanitized, and if it's outside of the expected boundary, then it's explicitly rejected. All right, so again, web applications must be designed to handle the unexpected. Never assume the happy path, so that you're not unhappy when it's not taken. So just keep that in mind. So let's talk about the first attack, cross-site scripting. Now, this one is it's not properly named because there's nothing cross-site about it. It was a name that Microsoft provided. I believe it was Microsoft, a while back, and it stuck, and now everybody calls them. You'll see XSS for short, but cross-site scripting attacks are discussed everywhere. It allows an attacker to completely bypass that same origin policy. So Paul talked about the same origin policy. What that does is ensures that you have, that a random server, you have multiple tabs open in the browser, and you're connected to multiple servers, and your bank.com server and your email.com server. Let's say you click a link on a malicious email, it shouldn't just be able to go cross that boundary and go into bank.com and perform a malicious action based on, let's say, a JavaScript injection. So same origin policy ensures that only valid content from the same origin is allowed to execute, especially on when taking care of sensitive items. So you have session information available. So if you're logged into your bank, that means that because HTTP is stateless, it usually has some session information stored so that when you go from one page to the other, you're not constantly logging in every time, right? So, but this session information is meant only for that same origin, you know? So somebody else should not be just able to come into this boundary and start generating valid, session information or session-based attacks against your bank, let's say. So this is so this whole XSS scenario, it's basically content injection in which malicious JavaScript is injected in a valid HTTP response from the origin. So we'll go through what this looks like in a second. And I know it's a little confusing. It's confusing for a lot of people, especially if you're new to it. In fact, it's so confusing, when you're first introduced to it, that a lot of the times this XSS and CSRF, these kind of attacks that we're going through, are used by interviewers to kind of select candidates. So if you're applying for a web application security position, or even if you're applying to a web application developer position, and they want to kind of see what your experience is with security, they'll probably ask you questions about XSS, CSRF, etc. So it's okay if you don't get it at first. It'll become clearer as we go through some of these examples. So cross-site scripting, same origin policy as we have been discussing. This allows an attacker script from interacting cross origin. So in an XSS attack, malicious JavaScript is smuggled inside a legitimate HTTP response. So first of all, what will happen if we weren't talking about an XSS scenario? Let's say we have an attacker at origin B. So the attacker, using their web server, or because you happen to go on a malicious web link, they somehow got you to click on something and is executing, let's say, some JavaScript. Now, that JavaScript operates within its own origin boundary. So that's denoted by that origin B on the left side. And then that origin B cannot interact with the elements, the secure elements in origin A, which in origin A in our case is chase.com. So if the attacker has some malicious JavaScript using which they want to use your chase.com, the fact that you're connected to Chase, you're logged into chase.com right now, an example bank. If they want to take you to an account transfer page and transfer some money into their account, they can't do that because the attack originated from origin B, and that's separate from the boundary of origin A. And origin A is where that chase.com or that bank.com session information and other secure information is stored. So SOP, or same origin policy, will prevent these kind of scenarios from happening. But if, let's say, that bank server is vulnerable to an XSS attack. So what happens then is, in an XSS attack, malicious JavaScript is smuggled inside a legitimate HTTP response. So it's executed inside the origin. So I think it's best explained with some examples. The attacker is able to get chase.com to serve you that malicious XSS or that malicious JavaScript within that origin A boundary. So if the response is validated, or if basically this attack is validated by chase.com because it's vulnerable to XSS, then it will be allowed to execute within the origin A because now it originated from Chase. So I'll show you an example. So what's important here for you to understand is, because in this case, the bank is vulnerable, or the bank server or the web application is vulnerable to XSS, we can get chase.com to serve us that malicious JavaScript. And there's a few ways to do that. We'll talk through some of those in a moment. So yes, iframes can make web apps vulnerable to XSS as well. And we'll go through some of these scenarios in a bit here. So, but good question though. So let's see. Right, so the idea here, again, is to get chase.com, if it's vulnerable to XSS, to reflect back, let's say, that JavaScript, which can then now, because it originated from Chase, it's within that origin boundary and will now be able to execute with all of its malicious payloads. So how do you do that? How do you get chase.com to do that? Well, first of all, I must emphasize that chase.com is not actually vulnerable to XSS. They have good security. If it is, then that's not the purpose of this exercise. It's basically providing you an example that you can relate to your bank, right? If you do find a Chase vulnerable to XSS, I believe they have a bug bounty program, so you can report it to them responsibly, and you'll probably be given a handsome reward for that. So just so everyone's aware. So reflected XSS. That's one way to do it. So the attacker is able to load JavaScript from a trusted origin by reflecting it up to and back from the server. So usually by sending a crafted link to a victim with the JS payload embedded. So this is what the attack would look like. You will send the victim a link, and a link that says chase.com, so a valid server address. But then you also injected some XSS, which, imagine this is some kind of malicious JavaScript that's also at the end. Now you've got the victim to click on this link. And there's a lot of ways to do that, social engineering. And basically victims are more likely to trust it because it says right there, chase.com. And when they go on the page, ultimately after clicking on it, the page will say it's an authentic chase.com page. Now, what they don't realize is there is some malicious JavaScript, within the URL that's also present. So the victim clicks on it, their browser initiates a request to chase.com with that little XSS hidden in there. It's not really hidden, but it's, as far as the victim is concerned, they don't really understand what they're looking at most of the time. These are, your average computer users. They don't really know what's going on in the URL. As far as they're concerned, it's a valid Chase address. So it goes there. Now, the server is vulnerable to XSS. So at this point, the server, and this is called a reflected XSS because the server will respond with the content and that XSS back to the victim. So we are able to get the server to reflect that malicious payload, that JavaScript or that XSS back to the victim. So what is the benefit in doing that? So we got the server to reflect back that malicious payload to the victim. So what's our benefit here? What are we able to bypass?
Able to bypass cores, or is it CSRF?
Yeah, so actually got a comment from the chat. It's the same origin policy, right? So think about it this way. The same origin policy was trying to prevent anything outside of that Chase origin boundary or your bank origin boundary to execute within the bank context or that sensitive information. But now you've got that bank to reflect back and send you that malicious payload or that XSS or that malicious JavaScript. Well, in this case, now when this XSS executes or this malicious payload executes, it's executing within the chase.com boundary in your browser. That means it has access to those, sensitive information stored within that Chase boundary. That includes your session information. So that means it's now that JavaScript is executing with valid session to Chase. So now if the request within that JavaScript payload was to transfer money to this account, if that was the JavaScript, that was the action that it was performing, before this, it will be blocked because it doesn't have the session information because of same origin policy. But now, because it is reflected back from Chase, it now has access to all of that. It's a valid request. It will go to the server with all the session information. So we'll recognize that, yes, all the session information is there. We'll execute it, and the transaction would happen. So this is how an attacker is able to initiate a money transfer bypassing the same origin policy. So I know there's a lot I said here. I'm going to take a pause and see if there's any questions on reflected XSS.
I have a question.
Yep.
So if this happens to, like, say one of us, for instance, we click like a bad link or something, how do we stop it from taking?
Yeah. So in this case, it's actually difficult for you to stop it because it's outside of it's transparent to the user, these kind of things, right? And that's why we're discussing it in the context of web application security. So if you're a so I don't know if you're asking from a perspective of a user, like a bank user,
Yeah,
or from the perspective of a user.
Yeah.
Yeah, so it's difficult because this is up to, that's why we get, we're talking about web application security, because it's up to the web application developer and the, and the security team there to kind of make sure that the server is resistant, or that their application is resistant to this kind of XSS attacks, right? So we'll talk about how to do that in a minute, but basically our objective is to make sure that the server does not reflect back, or the application does not reflect back the XSS. So that's where you'll try to stop it. As a victim, as a normal bank user, you'll click on it, the server will serve you the page. There's nothing much that you can do except not click on links that look suspicious, because what happens is, in this case, a lot of the users realistically are not equipped to look at the URL and be able to say that, okay, well, this looks like a malicious payload, I'm not going to click on this link, right? They'll just see the chase.com, and after that, whatever details, I mean, yeah, you can social engineer them into clicking that. Once the click happens, because the application is vulnerable, there's this thing happens very quickly, like in a second in the background, right? So how you would stop it, as a web application developer, that's why we're discussing how to design secure applications. As a user, there's very little that you can do except not clicking the link, but that's hard. Links were designed to be clicked. How is that? So a question from the chat: how is the JavaScript embedded in the link? So we'll go through. This is just the kind of examples that we'll be providing you, later in the slides today, but also in the CTF and stuff, right? You'll see some examples of that on how to embed these kind of details within the link or the URL. So we'll get to it, Michael. I first want to talk about the three main types of XSS before we move on. So stored XSS is another type of XSS. So think of this. This one was a reflected XSS. You send somebody a link, they clicked on the link, it was reflected by the server, boom, the transfer happened, or something else malicious can happen, and then poof, it goes away because there is no persistence here. It was done on the fly. You clicked on it, it infected you, bam, end the story, right? But this is a stored XSS. So when a server is vulnerable to a stored XSS, basically an attacker is able to permanently store something on chase.com, which will be served to all the users that are visiting, in this case, chase.com, yourbank.com, or any of those other web applications that you use in your daily life. So how is an attacker able to do that? So basically, in this case, let's think about you've designed a web application and you have, a comment section in the web application. Basically, anywhere where you're expecting user input and then storing it in a database in the background because it's needed on a future date. So if you're visiting a blog and they have a comment section, of course, those comments need to be stored. That's input taken from the users. Then they're stored somewhere, right? And then when some other users at a later point visit this page, they will be shown those comments that were, stored earlier, that were gathered from other users. So that's an example of how the attackers or someone, are able to store XSS on the server. So now what happens is usually you're embedding a payload in a persistent field. So like I said, the comment section affects any user who visits the correct page at a later point in time. So over here, notice the difference between the two. The reflected XSS, you send the link to the victim directly, a victim clicks on it, and the server reflects back that XSS, right? Over here, you're directly trying to target the server and loading up their pages, seeing where they take user input, and if that user input is going to be persistent, and if it is, let's try to inject some XSS on there so that when some other user visits that page later on, instead of a comment, they're served a JavaScript, which is malicious. So what's happening here is that XSS gets stored in a database. Next time some kind of victim or like a user browses to that specific page infected with the XSS, they will be served that content plus the XSS. So this would be, let's say, the comment section. They're shown the comments, but instead of a comment is actually a stored XSS that executes JavaScript in their client. And they've got a valid session with Chase right now, so you can imagine the same scenario of transferring, initiating a money transfer can happen here as well. So that's stored XSS. Any questions on stored XSS before we move on? All right. Feel free to interrupt me at any point if you do come up with any questions. So the third type of XSS that you need to understand is the DOM-based XSS. And this is why Paul talked about DOM in the beginning in the Web 101 portion. So, and I'm happy to see in chat that folks responded with, you're familiar with the DOM and you have been learning it through this course. So that's great because this will make it easier for you to understand the DOM-based XSS. So an attacker is able to load JavaScript from a trusted origin by passing it into dynamic JS that is already loaded and executing, right? So to give you an example, let's say your web application, among other things, it's taking in user input. Let's say in this case, a name. You said, hi, my name is John, and you provided that as an input to the web application server. The server takes that input and goes, hi, John, how are you today? This is the weather where you're located. So your server is trying to do its thing, whatever you've designed it to do. However, part of this was taking the user input and then providing it back, right? So that's where you have an opportunity. You're doing the server is already doing some dynamic, as part of web applications today, we discussed like with Django, with Django, Angular, React, and all. There's already JavaScript executing within the DOM. Now, in any of these variables, basically, can we inject malicious JavaScript and get it to execute within that DOM? Because if it does, again, same origin policy is off the table, because now it's executing within that secure boundary that we talked about, where it's a valid session, and now we can do the similar kind of. So if you look at the diagram, we tell the user, hey, click on this link, chase.com/foo, which is, let's say, a variable that your web application is already expecting. And then you provide some XSS there. You're trying to inject that as part of the variable. Now, basically what will happen is the web application is, if you don't secure the web application properly, it will take that into the variable field and will start executing, because it's not properly handling that variable value. It will start executing the JavaScript within the secure boundary. So if you've got the XSS injected here, the victim clicks on it, it's the valid chase.com origin. It has a valid application.js or app.js that is already executing, within the DOM in your browser. But now we've got an XSS or malicious JavaScript to be injected into that variable within the application.js. So now that will get executed along with the legitimate JavaScript that you already had there. So that's the DOM-based XSS. And again, I know that if you're getting introduced to these things for the first time, it's confusing. Trust me. I mean, they use it in interview questions because it can be confusing for folks. And so that's why they use that to weed out some of the candidates who understand, who don't understand web security as well as the other ones do. So basically, my point is, if it's not immediately clear to you, that's all right. We're going to do some exercises tomorrow, and I'll show you some examples as well, where you will be exposed to some of these concepts better. It's always better to do these things than read or see the theory. But having said that, these are the three kind of XSS attacks. Now, before I move on to the next part, are there any questions on these parts? DOM, stored, and reflected. All right. I'm not seeing anything, so I'll move on. Let me know if later on you come up with any questions. So a lot of the times you'll see web application testers, pen testers, to write a script, something like this, alert one, right? They'll say script tag, alert one, or alert XSS, and script tag, right? Or close script tag. And why are they trying to, and you'll see them trying to inject that into the search bar or into the comment section or wherever there's user input. Why are they doing it? So does anybody know why are they trying to do an alert one such that this kind of pops up?
It just shows that it's possible.
Yeah, exactly. It's just a what we call a POC, or a proof of concept, right? It's just showing you what's that. It just shows the tester that the application server is actually executing the script that I injected into the input field. So instead of a proper sanitization happening in the background where it takes that and recognizes, oh, this is a script, this can be malicious, I should not be, provided a JavaScript in, let's say, a search bar. Like, what is the reason for a user to type JavaScript into a search bar or into the comment section? There is no reason. So that should be sanitized, right? But it wasn't. In fact, it got executed. And that's why this pop-up, because the alert one is basically will pop up, and then it's a dialog box. So it popped up, and so that now the application tester, or if it's a malicious hacker, now they know that you're not doing proper sanitization in your web application, and now they know they've got you, right? So from this point on, if it's a web application tester, they'll just report their findings to show that, okay, well, you're vulnerable, you need to fix it. If it's an attacker, they'll start crafting malicious payloads, right? So that's what it's for, really. So you'll see the alert one, kind of discussed here and there, but that's what it's meant for. It's very visual, easy to spot. it's not the one or the XSS. You can write anything there and print it out on the screen. The point is like hello world. You're able to say that, okay, well, I printed something. So that's the only point of it. So that's the point. Now, what can you do? Well, like we've been discussing since the beginning, the same origin policy no longer applies. The basis of web security is over. All of your session information for that bank or for whatever sensitive website you're on, let's say your email, it doesn't ask you to constantly log in, because same origin policy knows that, okay, well, you're within the same origin, so I don't need to repeatedly. Otherwise, how annoying would it be if every time we open a new page on the application, we're entering our password again? But now, because of XSS, that SOP has been bypassed. So a different origin is able to, execute JavaScript within that context and using the valid session information. And that's where the problem is. Now we're able to read sensitive data like cookies, session information, local storage, all of these kind of things. So that's the problem of XSS. SOP no longer applies. And it's basically a total takeover of your browser session with that specific server. So in summary, XSS is really just content injection. An attacker is able to inject malicious JavaScript into an origin's response. Since the malicious JavaScript comes from the origin, the browser trusts it, right? And I've been emphasizing this point since the beginning, because it is within that, as far as the browser is concerned, okay, yeah, well, this looks like it's from yourbank.com. I trust it. And so it has, here you go, you have keys to the kingdom. And that's where the problem, therein the problem lies. So same SOP does not apply. JavaScript is all powerful. And then combine that with the fact that that's why I discussed in the beginning, with using JavaScript, you can write full-blown malware. I did a talk at Amazon a while ago. It's on YouTube. It was called Raiders of the JavaScript-based malware, where I'm talking about all the JavaScript malware that I've encountered. One of them was cryptojacking. One of them was a full-blown ransomware somebody wrote in JavaScript. And that is to tell you that JavaScript is Turing complete programming language. It can do anything. So people think of JavaScript in the context of the browser, but it's very powerful. So once they are able to execute JavaScript within the victim's browser with SOP no longer applying, basically they can do anything. So they're only limited by their imagination at that point. So it's a full read-write access within the origin. And that's why you'll see XSS discussed a lot. And that's why OWASP highlights it as one of the top 10. It doesn't call it out explicitly anymore, but it's tucked under the many content injection attacks. But you'll see if you're attending an interview where they're conscious of security, they might ask you, okay, well, how would you secure against XSS, etc. So let's talk about how you will secure against XSS. It's all about injecting content into the DOM, which the browser interprets. So never insert untrusted data into the DOM directly, right? So you have control over the web application when you're writing it, when you're building it. So if you're taking data from input fields, and this is why the golden rule of web security, right? All user input is evil unless proven otherwise. So never insert that untrusted data into the DOM directly. Validate the input, and that's where input validation and sanitization comes into the picture. Validating means, okay, well, I'm expecting a zip code, or I'm expecting a phone number, and you're entering all kinds of alphanumeric strings into, and the length doesn't match. We know that zip code is a very specific format. It's numbers only, 5 numbers, So basically you could write rules to validate it. If it's outside that valid boundary, reject it, but your application needs to be built that way. Sanitization, remove special characters and clean the input. So that means, anything that is unexpected, that is outside of that expected boundary, you need to remove that. So a lot of the times, and I'll show you the example of that in the next one, in the next slide, but you need to make sure that your web application sanitizes or cleans the all kinds of dirty and expected input that a user is going to put into it. So output encoding, escape or encode all special characters in HTML responses or when inserted into the DOM. So let's take a look at it here. I think it's clearer when we take a look at examples. So on the server side, like we were talking about Django, and basically Django has the escape, which escapes the strings HTML. So sometimes you'll see on web servers or websites if you visit it, and they're, they'll take the input, and when they're outputting something back to you, they'll have a little actual and quote written there instead of the single quote that you were expecting. So instead of the symbol, you'll get the and quote. That's because in the background, it's doing some basic, mitigation to escape anything that it deems could be problematic. So these symbols are converted to these, string replacements. So why that is because some of these things like single quotes and stuff, and I'll show you examples, they are associated with malicious attempts. So encoding, some of the frameworks like Django will do it automatically. That happens on the server side. On the client side, if you're writing applications, never write untrusted content into the DOM directly. So avoid inner HTML and use inner text instead, right? And some of the details, it's a lot to go over during the allocated time, but I want to make sure that the slides, because you'll have the slides. If not, you'll at least have the video. Feel free to look these things up on your own as well, like DOM purify and some of these methods, some of these mitigations for XSS. Research them further so that you're always performing the mitigation and always thinking about bad user input and performing sanitization and encoding, etc., to bypass anything bad that the users may provide your application. So before we do the CSRF, we'll take 5 minutes. Is that good with everybody? Yep. And when we'll come back, we'll see if there's any questions on XSS before I move on to CSRF. But otherwise, it's 11:27. We'll meet back at 11:32 my time. So 32. All right. All right. Everybody should be back. I just see you on my screen, Eric. So you and now Marion as well. So I'm taking the presence of a few as indicators that we're all back. All right. So let's resume and talk about CSRF, and then we'll talk about some SQL injection as well, everybody's favorite. So before we do that, Michael asked a question in the chat, how is that JavaScript embedded in that link, regarding XSS? I'll put a link there which shows you exactly how that is done. By the way, that company, Portswigger, is the company behind Burp Suite Proxy. So just take a look. They have some other good pages there on web application security as well, if you want to use that as reference later on. So, all right, let's talk about cross-site request forgery. So CSRF is one of the well-known web application security attacks. It's not as prevalent now as it used to be, but it's still an important concept for you to understand, and it still exists, just not as much as it used to. So it's just another bypass of same origin policy, if you want to think of it that way. It's according to SOP, resources loaded from one origin should not be able to write data into another origin. And by now, I'm assuming this concept is clear to everybody. There are two notable exceptions to SOP. So HTML requests, if you're doing a simple HTML request, or if you're using cookies to establish session information, etc. So in those cases, SOP is off the table. SOP does not apply. So CSRF abuses both of these. And again, I won't go with the SOP and how it stops attacks from one origin into another origin, executing on another origin, and so on. But CSRF basically is a workaround. So the objective of CSRF is to, again, steal those cookies, etc. And it makes use of simple HTML requests and all. So the anatomy of a CSRF attacks looks something like this. You've got you should have a state changing request. So there's some requirements for an attacker to perform CSRF. They can't just perform it on a simple index.html where there's no change happening. You're just viewing a web page. So if it's just a simple read request on a web page, it's not going to happen. It has to change something. So that means a post request that writes data or performs an action. So something has to change on server side. And a cookie-based authentication. So if your web application is not using cookies, you're not going to be vulnerable to CSRF. So if the applications that are using cookies, that is what CSRF will target. User interaction. So there's some user interaction required. So like stored XSS, if you think back to where I provided the example, where in a comment section, if you just go and visit a comment section and it just serves you that XSS again and executes the JavaScript, you don't need to take any action except just visit the web page. They didn't need to get you to click on anything because they already injected the XSS or the malicious JavaScript as part of the page. But over here in CSRF, user interaction is needed. So the victim must visit the attacker's site or click a link. So those are the three conditions that are required for a CSRF attack to happen. Now, what it abuses is HTTP's stateless nature. The stateless nature of HTTP basically means HTTP does not know one page or one request from the other, right? So it cannot distinguish between a legitimate request from a forced one. The browser's cookie behavior. Browsers try to be very helpful with cookies, right? So if cookies are automatically sent, so all cookies that are present on your browser, they will be automatically sent to the matching domains. So, okay, well, here's a cookie for your bank.com because I see you're on bank.com, you must need these cookies that are stored here. So that's what it tries to abuse. And then HTML requests, because HTML requests are not subject to the SOP, you know. So those are the things that you need to keep in mind for the CSRF attack. Now, let's take a look at the scenario. I think these diagrams are better explaining this than text. So the attacker sends a link, and it's from, notice the difference between XSS and CSRF. Over there, it was still www.chase.com or yourbank.com or legitimate.com and then /some XSS. But over here, it's now, because it's cross-site request forgery, they can do it from attacker.com CSRF. So then your browser, and the objective is to send you somehow to steal session information or cookies for chase.com or whatever their target is. So now what will happen is, if you visit the link, like I said, user interaction needs to happen. So you click on the link, it'll go to attacker.com and say, hey, I need to get this CSRF because you just clicked on the link. So your browser will request it. The attacker will be like, okay, here's the cross-site request forgery HTML. I mean, it won't be called that, right? I mean, they'll probably masquerade it better so that you click on the link. But for our purposes, I'm just highlighting that it's CSRF. So they'll serve you that malicious HTML. And then that malicious HTML is then going to post. Remember, I said it needs to change something. Some state needs to change, post to chase.com, and then using the cookies that are already stored on your browser, so that this would be a valid request then. So how this happens is, so like I said, the post to chase.com includes the user's cookies. So the server thinks, okay, it's legitimate. I got the cookies and everything from the browser. So the trick here is, you visit attacker.com, they serve you the CSRF, and the CSRF is basically including the cookies because the browser includes the cookies and then sends this to Chase. Chase thinks it's valid because they've got the cookies in there. SOP does not apply because, as we discussed, this is simple HTML, and also this is, so they didn't use any JavaScript at this point. They just used web-based forms, and so SOP did not apply. So let's take an example of what this looks like. So remember this part right here. This is the get CSRF part, right? So CSRF HTML. This is what the attacker is serving you, right? That's making you go to this target. So what is part of this CSRF HTML? Well, it kind of looks something like this. So the attacker's domain will serve you this HTML. In this HTML, you'll notice that there's this web form. So, and we've just inserted a little line here that's saying, okay, it'll submit automatically and use your cookies, right? But that's not important. The important part is this form right here. The form is called CSRF. It will probably be called something different in the real world CSRF. There's a method post. Remember, I said it needs to post something, or it needs to make a change, a state change. That action that it's taking is on chase.com account transfer. In this case, the attacker's target is to initiate a transfer so that they can get some money, right? It's a to value, which user to send the money to, which is probably going to be the attacker's name or attacker's ID, bank ID. And then it's going to include the amount, let's say $1,000. Now this is the form. And then they'll have a little bit of a script right there, tag, to execute to submit the form, right? So it'll take the form, it'll submit it, where? On chase.com. Now, there was no JavaScript, and because of that, the same origin policy is not into play. And because that's the case, this will, the server will automatically see will act on it because the browser will automatically include the cookies. So, all right, so let's take a look. So if you intercept this, so this is a Burp Suite proxy, by the way, where we've intercepted the request. So what you'll see is, so what is the stage? Well, this stage is this final part, this post part right here, right? So once You go to attacker, you get the CSRF, they send you the CSRF HTML, and then that rep form is sending you here. Now, this part right here, if you were to intercept this part, post account, it will look something like this, because now this is a request going to chase.com, a valid bank, your valid bank. And notice here the origin is localhost because we were trying this attack on a local machine. So that's why it originated. In the real world, if this will be the attacker's domain, because that's where you originally clicked the link. That's the originator. And then, so that's the referrer. But then you're seeing that it's including that cookie, all of those details that are supposed to stay within the origin. But because same origin policy is not applicable, and it just tricked you into, clicking on this link, without the SOP applied, it's now sending all that cookie information and all of that to your bank. So, well, the bank is going to see this, and we go, well, this looks like it's valid. Now, Chase is not actually vulnerable to this, but the point is, if it was, then this is what's going to happen, right? And you'll see that the to and the amount. By the way, you'll get plenty of chance to play tomorrow with Burp Suite proxy, so don't worry too much about this interface. Just know that we've intercepted the request, the final part of it that's going out to the bank, and we're inspecting it to see what the attack would look like. So that's the CSRF payload. Now, let's pause here. Any questions?
Yeah, I have a question about, so you said the origin would be from the, like the attacker's server?
Yeah,
And so
exactly.
would cross-site scripting be different in that regard? Would it be showing that it's
Yes.
from the victim?
Yeah, exactly right. Yeah, you got it. Because XSS will not, XSS has that same origin policy conditions still applicable. And because of that, it just will not allow a different referrer to execute something within that origin, right? And because of that, if you were to intercept those bad requests, you'll still see the origin is, chase.com. So, it depends on who's sending you where, because that's where that origin or that referrer information comes from. But yeah, you're basically right. In CSRF, you'll see that we're able to do, and this is why it's called cross-site request forgery, because you're able to go from attacker domain, which is your referrer or the origin, to the other one, because we're able to pass that boundary, because SOP is no longer applying, because SOP only applies when JavaScript is in picture and all that, and we use a simple web form, and we use HTML web form, and it's basically was using cookies, and we're stealing the cookie here, or using the cookie to authenticate. So yeah, you're right.
Okay, thank you.
Yep. That's a good question though. So any other questions? All right. Like I said, if you have any questions at any time, feel free to interrupt me during the presentation as well. So how do we prevent against this kind of thing? Well, because of the browser's overly helpful behavior with cookies, it is up to the server to verify the request. The browser will send the cookie, because the browser is like, oh, you're trying to go to chase.com. I got some chase.com cookies right here. Let me send that along with your request. So, and that will end up being bad. So so on the server side, you have to client side, you can't. Server side, you have to try to prevent against it. So traditional defense is through synchronizer tokens. So this is a random value that is appended to each form. And when the form is submitted, the server syncs the tokens to make sure that they match. So that's just an extra form of validation to make sure that the request is an authentic, legitimate request, and not basically what we just discussed. So it requires remembering state server side frameworks will be helpful here. So a better or easier method that I want you guys to focus on is to use same origin policy, right? The same origin policy that has been our friend all this time. SOP, though, just know that it only applies to JavaScript. So if each form submission requires some JavaScript, SOP will kick in. And as soon as SOP kicks in, it will not allow this to happen, that some other referrer or origin is able to send a request to our bank or our target like this. So make sure that it's using at least some JavaScript, and each form requires that some JavaScript to be used so that SOP can kick in. So with SOP, don't accept state changing requests via pure HTML. Like I said, require a little JavaScript as part of that. There's two approaches, right? You can use double submit cookies. So a random value that is submitted in both the cookie and the body. In JavaScript, and there's a lot of text here. You can look up some of these methods on your own as well. But the point is, we're trying to make sure that there's some extra validation that's happening, so that these kind of attacks cannot happen. An important part of this is if you choose to not use cookies at all and use other kinds of session management, then that will help too, because if your app doesn't use cookies for authentication, CSRF goes away. Cookies are dangerous in a way, because with these kind of things, you can trick a cookie to be submitted, and now the cookie was the only thing that was authenticating, and now attacker just tricked your cookie to be submitted to the web. So there has to be other options that you consider if you just want to not deal with CSRF. So like I said in the beginning, for CSRF to happen, cookies was one of the conditions. So this is an example of double submit. I'm not sure we have the time to go over this one, since we do want to cover the injection, the SQL injection as well. But Krishik will be showing you some examples tomorrow on CSRF and the CTF. So we can discuss this tomorrow as well. But basically, to summarize this is what it looks like, double submit. Basically, you have an extra CSRF token that your application also expects. It's added to the web form, and basically, if you're using the JavaScript to send the form on click, and there's a CSRF token cookie value now that is added to the form, and that's used to further validate. We have a custom header example as well. Another example on how to mitigate against it. Let's see. The idea is the same in all of these examples. There's multiple ways of doing the same thing. So like I said, multiple ways of skinning the cat. The idea is the same. You have an extra validator. So in this case, it becomes this custom header. So, you say, well, this is the value, X XSRF token, no CSRF here. So that's it's just another way to add some validation. So for the summary, CSRF abuses legacy HTML, right? Like I said, they're not around as much anymore as they used to be, because it looks to exploit the legacy pure HTML pages and the cookie behavior to not invoke the same origin policy. So completely skip that by using these two. And then it requires, we've been discussing it, cookie-based authentication and HTML forms and requests, like we discussed the web form that I showed in the example. It allows an attacker to write data cross-origin without invoking the SOP. It's easily prevented though by forcing the SOP. So like I said, just use a little bit of JavaScript to read the cookies or set the custom headers. All right, we have the final part, injection, coming up, and this won't take long, but it'll be interesting. Any questions? Okay, so we have some messages in the chat. Let's see. Yep. Thanks, Paul, for responding, by the way. All right, so any other questions, or are we good to move on to injection? I'll take a moment. All right. Again, you'll have a chance to practice these things tomorrow. So we can also, and you have a 3-hour session tomorrow to actually try this on some of the vulnerable web applications and get your hands dirty, try to do this yourself, and then it'll become clearer. Hey, Jesse, I see your question. Will we get the slides too? I think so. Yeah. I mean, I think Code Platoon already has the slides. So I would ask the organizers to distribute it some way to all the attendees. All right, so let's talk about injection. Injection is number 1 on the OS top 10, right? Inject, what's the point of it? Inject bad stuff into a web application that is not designed to handle bad stuff. And the bad stuff does bad things, right? That's pretty straightforward. Now, it's a server-side vulnerability because your server is not handling the input correctly and is, basically falling prey to some of these attacks. So how that happens, we'll see. Target the server's handling of unexpected or untrusted input. Follow the golden rule, right? You're getting some weird SQL commands in your input field. Probably not best to pass that back to the backend server and ask it to execute it, right? Because that's going to be really bad. So can take many forms depending on the technology in use. If you're talking about databases right now, we're talking about SQL injection. You can also do command injection. There's server-side template. There's all kinds of injection, right? The idea is the same. Bad content being processed when it should have been rejected. So it usually occurs when a server takes input and translates it. So what does that mean? Take an input from HTTP and execute an SQL command. So this is our browser, this is our web server, and the web server in the backend will usually have a backend database server where it's as part of building your application, you're storing usernames, and passwords, you're storing usernames, addresses, and all kinds of information, right? And all of that information is not kept on the server. It goes to the backend to be stored in a database server. So when an input is taken from the form, you say, hey, I want to register on your web application. My username is going to be this, my name is this, and my address is this. The server takes that input form, processes it, takes those fields, puts it in the database, right, for storage so that it remembers you. And that's the SQL queries in the background. So now we have something like this happening in this backend request. Or in this case, the client could be asking for, hey, for this is my username, and if the web application design say, hey, username, this is the weather today, then you're providing this username, but in the backend, what's happening is it's trying to see, or if you're trying to log in, it's trying to see if that username is present in the table, because you want to see if this user has registered before and is a valid user. So this is the kind of query that will get executed in the backend, right? Select all from users where username equals, am I root yet? So that's what the web server does in its natural state, right? I mean, it's just communicating between the database and the end user right now. Now, what's bad here is if we can get this to happen, right? If untrusted user input is used to construct other commands, bad things can happen. And this is a very popular example of injection, or SQL injection in particular. So you might have seen this one before. Can anybody tell me what this statement here is going to be doing?
We'll select everything from table users where the column username is equal to the string admin, or just 1 equals 1.
Yep. So what would be the result of that?
And so by putting in admin with a single quote or true, it's basically saying constantly drop everything from table users.
Yeah, so you're close. It's basically this, you said it correctly. This is the true part, right? Because it's saying select all from users where username is admin or 1 equals 1. Now I've inserted a condition which is always true, and then I said or. I didn't say and, I said or. So where either the username is admin or 1 equals 1, and 1 always equals 1. So this condition, everything after the where clause, this is always true. This means it selects basically everything, right? This is just ending the query at the end. And the effect of this would be, you've taken something that it's supposed to, there was a conditional clause there where something matches something. You took that conditional clause and removed the condition effectively, because you said, you know, where 1 equals 1 or 1 equals 1. And or 1 equals 1 means always true, which means you've effectively nullified the conditional clause that was checking for something. And why was this allowed to happen? Well, because you never sanitized the input that was going into the server, right? So when you asked the user to enter something in a form, they entered admin, and then they entered, like you said, Eric, they entered the quote or 1 equals 1, right? So effectively in the back end, and then you just gave that, the web server took it and then just gave it to the backend to process. And the backend doesn't know any better. At that point, it's just SQL. So the backend just took the username and or admin, and then inserted the single quote, which the to end that beginning quote in the SQL query, and then said or 1 equals 1, effectively nullifying the where clause, and then boom, you've just processed a bad query. Or a malicious query, and that is called SQL injection. Now this can do all kinds of nefarious things, right? You can drop tables, like you said. You can delete a lot of data. You can basically read. People dump entire passwords of all of the users in a web application using these kind of SQL injections, right? Because it is over here. I could write anything now. I know that I can get it to execute on the backend server. So now I just need to write SQL queries as part of this input field. The server will take it, or your application will take it, send it to the backend to execute. That will execute the SQL on the backend. It will take the response. Let's say I asked it to dump me all of the usernames and password combos, and it'll just put that back, give that back to the web application. And I'll just put it for me very nicely in front of me on a browser page, right? And now I see all of the, or dump it in a file. Basically, now I see all of their usernames. I know all of their passwords. If you're hashing the passwords, then that's where I take the hashes. I start cracking the hashes using one of the many password crackers. So that's the kind of bad things happen if you're not sanitizing the input. And we're at 12 here, but I have a few more slides, like a couple to go through. So if it's +5, is everybody okay with that? Or I don't know if any of the organizers are on the call. Okay, I'm seeing thumbs up. So we'll continue, just 5 more minutes. All right, so let's talk about, so that's what happens, that's what happens in an SQL injection. And tomorrow you can try some of these things yourself in the CTF, right? And you'll see the bad effects of these. Now, SQL lets you escape a normal SQL query and inject additional SQL, SQL parameters. So sometimes you need to be creative, because, I mean, this was a very simple example, right? Most of the times, like you want to encounter this in the real world too much, because an application would have to be really, really poorly written for this kind of or 1 equals 1 to work, right? So you'll mostly encounter this in CTFs, etc., but not so much in the real world. But in the real world, though, they'll try to put some rules, sanitization rules or validation rules in the query against the input. But then your job as a web application tester, is to try to bypass that. See if an attacker, a black hat or a bad guy can bypass that. So what you'll do is you'll need to get creative. So it can get queries can become really complex. So you can go like, and select this from select count concat, select from. It gets really, really long and complicated, right? Because you're just trying to bypass whatever filters the server has against SQL injection. So, you'll see a lot of use of union and join. This is where if you have knowledge on SQL, it will help you understand it better. But otherwise, just know that these kind of things exist, right? For SQL maps, so this is an open source tool that is very, very popular in performing automated SQL injections against web applications. So please do not use this on any live websites, right? Because you don't have privileges to pen test. You don't have authority to pen test those websites. It will start injecting, taking the user input forms and start injecting SQL, different combinations of these complex SQL injection queries in there, and then trying to see if it can get it to behave unexpectedly, dump out some data, get some error messages. You can get all kinds of information like what kind of SQL server they're running. And then from that point on, start constructing your attack. What kind of data structure do they have? What kind of tables? Within those tables, what kind of fields? And so on. So you can get the tool to do a lot of things. Like I said, again, word of caution, don't use it against live websites out there in the world. And two, just know that this tool is very good at what it's doing, but you should be able to first write manual SQL injection queries, at least the simple ones, so that you understand the concepts well. Otherwise, tools like this, if you go very early to tools like this, it will make you into what we call in security like a script kiddie who doesn't understand the base concepts very well, but it's just like basically, the tagline for Kali Linux, which is the penetration testers OS or the attackers or the hackers OS, is Kali Linux putting machine guns, equipping monkeys with machine guns since whatever year that their inception year was. So basically, that's what you'll be like. You don't want to be in a situation where it's like you don't understand the tool you're using. You get a really powerful weapon, but I'm sure everybody over here is from the military, so you understand how to use tools like this safely, and first understanding all the basics about that tool. You underestimate me. Yeah, probably. So this is a good tool to, be aware of it, watch it, try it out, if you want, but just never do it against a live actual web server. So I wouldn't go to Chase or any other bank and start SQL injection against. Yeah. So let's talk for a moment about mitigating SQL injections. Never trust user input, right? Again, we keep going back to this golden rule of being paranoid against user input, right? And that's there for a reason. Trust me, the security folks have encountered countless scenarios where user inputs were trusted. You just can't trust it, because even if you can trust 99% of your user base, that 1%, because your application is exposed to the internet, basically is exposed to those 1% of backers as well. So popular methods for doing these kind of things is basically escape everything. Use stored procedures, SQL, and object relational mappers. So whenever you find yourself writing raw SQL, reconsider. So if you're writing a web application and you have a database that you're trying to store information into, and you're writing something like this, like that example at the top. Select star from users where username equals, and then this is basically the variable username that you took from the web application and just passing it on to the database. Why that's bad, right? I mean, we just saw you can't just take a username and put it at the end of this SQL query and then just ask the database server to execute that, because that username can contain valid SQL that continues from this point where you left off, and then they'll get really crafty about doing really bad things to your server if you just ask the backend to execute that. So don't just execute things like this. So never write this kind of raw SQL queries, right? You can use things like this, user.objects.filter, name equals username, right? So that is a more, frameworks have libraries to interact with SQL in a safe manner. So that's what this example is right here that you see, the bottom one.
Question about that.
Yep.
Yeah, sorry to interrupt. So frameworks like Django that use ORM, we've all been using Django a lot. Is that essentially SQL injection proof, given the way it actually deals with its relational databases?
Yeah, it does a lot of the sanitization and kind of, it takes care of it covers a lot of bases for you in the background. I'm just not personally as familiar with Django to know if it covers everything. Krishik, do you happen to know if Django is completely, like, how SQL proof, injection proof is it?
So usually, if you are following the best practices, then you are safe. But sometimes, and I'm not an expert in the Django, but in many framework it works that way. That if you are using in the standard way, it is safe. But always you can enforce to create a raw query and pass the raw query to the database. So I think it's possible. However, the framework helps you to make it more secure.
Right.
I wanted to mention one comment about this one, because it's not mentioned here, because the best way to prevent from SQL injection, if you have to create a raw query, is a parameterized query. So you are providing separate SQL command and parameters to be used in this query. And this is also a safe method, not mentioned here explicitly.
Yeah, thanks, Krishik. Yeah, in the world of security, one of the things we know to always be true is there is no such thing as 100% security. What we're doing is raising the bar for the attacker, so it becomes increasingly difficult for them to perform or carry out their attacks. So if you use the standard methods like Krishik was mentioning, like with Django, and you're doing things the right way, these things in the background will take care of cover a lot of those bases for you. And that will keep you safe from the 99% of the stuff out there. Now, there's still some very crafty things that if somebody's really targeting your application in particular and spending a lot of resources on attacking it, then at that point, then there's some additional things that can be done. But particularly in Django, what those things are, I'm not aware. I hope that answers your question.
Oh, that's helpful. Thank you.
Yep. All right. Nothing is bulletproof, just bulletproof. I'm loving the chat. This is a good group. These are yeah. All right. Yeah, all military examples here. All right. So the section 3 that we'll have tomorrow will be led by Krishik. And Krishik, we all say, like, Paul and I are security architects, and we do a lot of things in the world of security, and we are not as close to the actual hands-on anymore as we used to be. But Krishik is definitely exposed to a lot of the hands-on components, and has also actively participated in a lot of CTFs. In fact, he was ranked 9th in one of the global challenges, across companies. So he, basically has a lot more knowledge on the CTF portion, and he'll be leading the labs tomorrow. What they'll give you a chance to do is, you've heard about a lot of these concepts today. You've seen the Burp Suite proxy tool, but tomorrow you'll actually get to load up. So Krishik, I don't know if you have any instructions for students for tomorrow, or you want them to load up Burp Suite or anything?
Yes, a short question. If you could prepare a Burp Suite, install Burp Suite on your machine, then everything should be fine. And I would like to mention also that these exercises for tomorrow will be split into the 2 parts. First will be some kind of hands-on lab, so we will go through all exercises together with my explanation how it works and why it works and why it's vulnerable, for example. And then the second part will be CTF, so you could try to hack by yourself.
Yeah,
to the
and
system.
we've got a prize at the end of the CTF, right?
Yes.
The person who gets #1 spot. I'm still to get clarity on what the prize exactly is, unless any of the organizers are on the call right now. But rest assured, it'll be something useful. So yeah, that's what the game plan is for tomorrow. By the way, Krzysiek is in Krakow. That's in Poland. So that's why we broke it into 2 days, because right now 9 to 12 for me Central Time is actually quite late over there, right? What time is it, Krzysiek, for you?
7 p.m.
7 p.m. right now. Okay, so that's why we kind of broke it into 2 halves for 2 different days. So Krzysiek can still do 9 to 12 tomorrow, 9 to 12 hour time. So basically, tomorrow we'll have the lab session, the practical session, where you'll get to get your hands dirty with a lot of these things we've been talking about. You guys did well today. You sat through a lot of the theory, and basically, I know that it's difficult just watching one concept after the other and talking about like one attack after the other, especially when you're getting introduced to it for the first time, to really make sense of all of it all together in your head. So take some time today to think about what we discussed. Look up OWASP, look at the top 10, and try to do some reading on the OWASP top 10 if you can, and think about how it applies to any web applications you might have built so far, and where you could have sanitized input better or anything like that. So, and then tomorrow, then we'll meet for the practical session. All right. We went 15 minutes over, so we'll close the session now, but feel free to bring up any questions if you have before we close the session. Otherwise, we have tomorrow as well.
I just had a question about the Burp Suite. Once we install it, we don't need to like create a project or do anything. We just need to have it downloaded.
Yeah, exactly. Just have it downloaded and have it installed. And once you get to that window, like once you start it and you get to that window where it says, load up a project or create a new project, it'll give you like a temporary project, as the default selection. So once you get that window, that's more than enough. That means you have it installed and running. The rest we can do tomorrow.
Okay, thank you.
Yep. Krzysiek, anything else you wanted to say before, because in preparation of your session tomorrow, or we're good?
No, that would be sufficient. Yes.
All right, sounds good. All right, well, thanks everybody for attending the session today, and yeah, you've all been great. We'll see you again tomorrow. All right, I'm going to pass the host privileges to. Let's see.
Yeah, I'm here. Actually, I'm here. Okay.
All right, there you go.
Passing the host privileges, I'd appreciate that. This is not me doing some kind of in-person phishing attempt. I'm an actual instructor.
Okay, got it. All right, does everybody vouch for Benjamin here? Nobody does. No, I'm kidding.
Never seen it, right?
All right, I executed at the speed of trust and made you the host. All right, there you go. All right, thank you all.
Okay, bye.
All right, you guys are free to go. You have lunch now. By the time you get back, the rooms should be back to how they are. If you're curious, you got to do it in Zoom on their website if you want the rooms to stay the rooms you want. Otherwise, every time you create breakout rooms, it's just for that session. So now I know. But yeah, you guys are free to go, and you're coming back at I guess what is 1 p.m. To work on group projects. And if you're still working on assignments and you plan on participating in the group projects, like I said, we want those submitted by tomorrow at noon for the sake of regrading. And please reach out to me directly if you want any more direct help. We really want the maximum number of people to participate in the group projects as can. So please reach out. Thanks.
Why are the CTF projects so secretive?
What do you mean?
everyone keeps saying prizes, and it's just like no one says what the prizes are.
That might just be part of the whole culture of security stuff. I don't know. I mean, by the nature of the CTF thing, they're definitely not going to tell you in advance what the vulnerability is that you're trying to discover. I'd imagine the reason they're saying that is because prizes are motivating. But if you know the prize and the prize doesn't appeal to you, it's not nearly as motivating. So the uncertainty as to the prize, which for all you know is a Lamborghini. I don't know if that's what you want, but the point is this could be a prize worth $1 billion and you'll just retire once you win this CTF competition. So, better show up, better win.
Ben, what were they just saying it earlier, just to read like over the top 10 stuff before tomorrow's session?
What was that?
Were they saying we need to do anything else other than install that program and read over the top 10 before tomorrow?
I believe that's it. The program's Burp Suite, right?
Yeah, you guys linked it in the Slack, right?
I believe so, yeah. It's sort of the standard go-to program for, I don't know why it's called that, but essentially like sniffing, knowing what's coming in, what's going out in minute detail.
Okay. All right, thanks.
Yeah, Moya's mentioning Wireshark. There's a bunch of them. But right, it's just giving you way more information than the Chrome Dev Console does in terms of what that request or response actually is. And if one digs in, sometimes one can learn information that can help with some nefarious or security related thing you want to do. Okay, I'm gonna make the breakout rooms still here.